All right, he should be signing on shortly. He better sign on because I don't have anything to talk about other than him. Oh, here he comes. Okay, good. There's Bill.
There we go. I guess get a little special effects in there.
Good, good. So
Accidentally.
so this is so Scott starts the meeting, like 10:07, he starts a stream going. In the meantime, before that we can have some idle banter if we want with anyone here.
The mics are hot, but that's okay. We're live right now.
Okay. Yeah, so keep it clean.
Keep the cursing to a mile.
So anyway, David Eicher was saying we're west of Philly, and like Tuesday nights ago started getting texts from people. They say, go outside and look up. So we went up about 9, saw a little bit. So we came in and watched a show, and we're back out at 10. I looked to the north, and it was really prominent. Mm-hmm. I looked to the west. It was there. I looked straight up. It was there. It was everywhere. It was amazing. It was everywhere around us.
Yeah, that was the best show in a few years.
I only ever saw it once before here, and that was like 20 years ago. So
wow,
it was incredible. I got some great, and it showed up better on the cell phone pictures than it was in reality. But I got pretty good pictures of it filling up the summer triangle.
Excellent! Wow, that's great.
It was a blast. And then a few days after that, we went to a local park and saw Comet Atlas.
Mm-hmm.
And that was really cool. It's really faded now. I saw it last Thursday, but it's really faded.
Yeah, maybe 6th magnitude by now.
Yeah, needed binoculars.
Good for a while there. Yeah.
Oh yeah, a naked eye comet and aurora within a week of each other. That was really special.
The first time I saw the comet was from Easter Island in the morning sky behind some of the Easter Island statues. So that was quite dramatic. It was very bright.
Wow.
That's an amazing sight to begin with.
Hello, familiar gentlemen. Kevin, Ian, how you doing?
See ya.
Hi.
How are you?
And thank you. Good to see everybody.
I'm looking forward to seeing so many of you in person in just a couple weeks.
It won't be long.
I think that's what everybody around here is terrorized about. It won't be long.
Right. Yeah.
About 2 or 3 times a century, a massive star in our galaxy explodes. The star's core may survive as a neutron star or a black hole, but the rest of it rushes into space as swiftly expanding debris behind a powerful shockwave. As the supernova remnant grows, it sweeps up interstellar gas and gradually decelerates. Yet even thousands of years later, its imprint on the galaxy remains impressive. Exploding stars and their remnants have long been suspected of producing cosmic rays, some of the fastest matter in the universe. Where and how these protons, electrons, and atomic nuclei are boosted to such high speeds has been an enduring mystery. Now, observations of 2 supernova remnants by NASA's Fermi Gamma Ray Space Telescope provide new insights. Because cosmic rays carry electric charge, their direction changes as they travel through magnetic fields. By the time the particles reach us, their paths are completely scrambled. We can't trace them back to their sources. So scientists must locate their origins by indirect means, which is where Fermi comes in. The interaction of high-energy particles with light and ordinary matter can produce gamma rays, the most powerful form of light. Unlike cosmic rays, gamma rays travel to us straight from their sources. In 1949, physicist Enrico Fermi worked out how what he called magnetized clouds could accelerate cosmic rays. Later studies showed that a variant of his method, called Fermi acceleration, worked especially well in supernova remnants. Confined by a magnetic field, high-energy particles move around randomly. Sometimes they cross the shockwave. With each round trip, they gain about 1% of their original energy. After dozens to hundreds of crossings, the particle is moving near the speed of light, and is finally able to escape. If the supernova remnant resides near a dense molecular cloud, some of those escaping cosmic rays may strike the gas and produce gamma rays. But electrons and protons make gamma rays in different ways. Cosmic ray electrons do so when they're deflected by passing near the nucleus of an atom. Accelerated protons may collide with an ordinary proton and produce a short-lived particle called a neutral pion. These pions quickly decay into a pair of gamma rays. At their brightest, both types of emission look very similar. Only with sensitive measurements at lower gamma ray energies can scientists determine which process is responsible. Now, Fermi observations have done just that. They conclusively show these supernova remnants are accelerating protons. When they strike protons in nearby molecular clouds, they produce pions, and ultimately, the gamma ray emission Fermi sees. NASA's Fermi has detected gamma rays from many more supernova remnants, but the jury is still out on whether accelerated protons are always responsible and what their maximum energies may be. Nevertheless, the Fermi team has taken a major step, a century after the discovery of cosmic rays, in establishing just where they arise. Something that would satisfy, but certainly not surprise, the original Fermi.
Well, hello, everyone. This is Scott Roberts from Explore Scientific. This is the 160th, can you believe it, David? 160th Global Star Party. We've been doing this for a few years now. It's been a lot of fun, a lot of adventure. I have learned a lot from listening to the lectures and speakers from Global Star Party. Certainly have not only of what's going on in astronomy, but I've learned a lot about the passion that people bring to educating others about our universe and our shared experience and discovery, which, by the way, will be the title and the theme of the next Global Star Party, our 161st. But I want to talk a little bit about this one. We have, of course, David Levy starting off every Global Star Party with some commentary and a poem. But this theme that we have, and I try to have a theme ready for every Global Star Party. I come up with some of them. David comes up with some. Sometimes we get themes suggested from our viewers or our other presenters, which we're happy to bring forth. But this one is a star stream, and there are all kinds of aspects of star streams. Some of them are galactic streams of stars that shape our cosmos. There are streams coming from our own star as it affects our own planet and the rest of the solar system. I think the most dramatic aspect of that for a lot of us recently was Comet Atlas, showing his beautiful tail. It was so big and bright and long, so that was fantastic. We will have also Don Nab. Don Nab is coming on with Bill McGeeney. Bill does a podcast called The Light Pollution News. And of course, light pollution is a big topic for many of us. In fact, I would say for all of us that are amateur astronomers and professional astronomers as well. Don writes that Bill's the regional rep for the Astronomical League for the Mideast region. And that he puts a lot into his podcast. So that's great. Hopefully, Bill, we can help spread the news about your program. We have special presentations from Kevin Schindler from Lowell Observatory and Ian McLennan, and they are going to be talking about the recently completed Astronomy Discovery Center, which David Levy and Ian and Kevin and a number of us are going to be there to help them celebrate that ribbon cutting ceremony. David Eicher is on as well, and he'll be talking about some of the most beautiful galaxies in the universe, or one of the most beautiful galaxies in the universe, I think. So, we always enjoy David's insight into the cosmos. So thanks for joining us today and being a part of this particular program, and feel free to chat, and we will try to answer your questions live. And I'll turn it over to you, David.
Well, thank you. Thank you very much, Scotty. And the last few days, I've been watching Comet Tsuchin Atlas very, very religiously every night, and it's been wonderful. And I want to congratulate David Eicher, who is one of the few people that knows how to pronounce the name of this comet. And it's worth learning to pronounce it, I think, to show respect for the discovery place, to show respect and love for the comet. And I'm thinking today, it's been kind of a rough day. It's been over 2 years now since I lost Wendy. And most of the time now, I'm getting into it. I'm getting back into living, back into life. And I'm looking at Wendy and having the memories. But then there's sometimes that things happen and I slip back into a real depression again. And today is one of those days. And it was very simple. I was just getting ready actually to come to this global star party. Sorry to blame you, Scott, but I was. And I just imagined Wendy sitting at her desk and flashing one of her smiling faces at me. And boy, did that get me upset. I really miss her so, so much. But my poem today is going to be is one that I know I have not read here yet. And it's by Hannah Sanesh, and it's called Yesh Koshavim. And it was supplied to us at the recent Yom Kippur services. We were at our synagogue, and the rabbi had a whole bunch of extra prayers. I don't even know if we did them during the service, but they were just extra prayers. And this one, I happened to see it, I read it, and it really overpowered me. And so that's what I'm going to share with you right now. There are stars up above. I don't think anybody will argue that point. And I'm thinking that for me, the stars are not just stars. And much as I enjoyed that lovely video that Scott just presented, I don't see the stars so much as astrophysical objects, but I see them the way Leslie Peltier saw them, as personal friends. I see the moon as a personal friend. I see certainly comets, like the one that's been in the sky lately, as personal friends, because I have a personal connection with these objects and something that has enriched my life and has made it so much joyful. There are stars up above, so far away, we only see their light long, long after the star itself is gone. And so it is with people that we loved. Their memories keep shining ever brightly, though their time with us is done. But the stars that light up the darkest night, these are the lights that guide us. As we live our days, these are the ways we remember. Thank you very much, Scotty. I'm back to you.
Okay. So let me bring us back here. It's nice that you do bring up Wendy, David, because she was on many global star parties and she was a great inspiration to many of us. So I appreciate it. So we will move on next to Don Nab from the Astronomical League, and he has a special treat for us. Don, let me bring you
And
your
And Bill on.
invited guest. Let's see. There you go.
okay,
And there we are. We got some cool mood lighting going on there. That's awesome.
spooky,
So-
Halloween spooky.
Yeah, thank you
Tis
so
the season.
much. Thank you so much. So, the Astronomical League is also a co-host of our event, and they have supported Global Star Party from the beginning, and they are preparing for their next Astronomical League convention. But I think that the thing that's also very important about the Astronomical League, aside from the fact that they are the world's largest federation of astronomical clubs and have a huge membership of, I think it's over 20,000 members. Is that right?
Yeah, something over
Yeah.
20,000, 22,000
Something like
maybe.
that,
Yeah.
and they're always looking for ways to help people become inspired through their award programs, through their teaching programs. They have so many observing programs, I think over 80 different programs that you can get involved with, including an astronomy outreach one, which would be my favorite. But I think it's cool, Don, that you brought this gentleman on, and I'm going to let you do the introduction and take it away.
So my role in the Astronomical League is that I'm chair of the Mideast region. So we have several officers that support the Mideast region. Bill this summer became the regional representative for the Mideast region. We call it Merrill, Mideast Region Astronomical League, Merrill. So Bill's a regional rep. He is a member of a club that is on the western outskirts of Philadelphia. It's one of the 4 clubs that I'm a member of. And I met Bill. The club is called Delaware Valley Amateur Astronomers. One thing unique about the club, when they have outreach events once a month, they do it at Valley Forge National Park. And they're always a lot of fun. Usually have a little bit of moon in the sky because, as you can imagine, close to Philly, it's very light polluted. But I've seen Bill there under the stars. I spent time with Bill at the York County Star Party for 2 years and got to know him a little bit. And I'm really glad he joined the Astronomical League officer. So Bill is when I talked to Bill under the stars, he mentioned this podcast called Light Pollution News, and of course I'm interested in that. Every amateur astronomer and professional should be interested. So I tuned into his podcast, and he's the host of Light Pollution News. Bill is a dark sky advocate. He's a member of the Pennsylvania chapter of Dark Sky International. He spends time in nature of the watershed steward, and he's a crew leader with a local conservancy group. But he started Light Pollution News as a way to explore the topics associated with light pollution and its environmental and ecological plight that we're in with it. His show presents an open and fair platform to discuss topics in the news as they pertain to light pollution. So I'll introduce Bill and let him take it from here.
Yeah, thanks a lot, Don, and thank you, Scott, because what you guys are doing here, this is a phenomenal show. So I really appreciate the opportunity. So thank you so much.
Thank you. Yeah, I'm looking at your website right now, which I'm going to post in chat. And I like the I like the tagline: "A podcast shedding the light only where needed." It's very cool.
Yeah. Let me get started here. I know Don asked me to do a little talk on light pollution. So, and I know this isn't going to be a topic that is foreign to anyone here or anyone listening or really anyone on this feed. If you don't mind, let me see if I can share some slides here, and I think I'm up and going. Okay.
Yep, coming through.
Excellent. As I go through here, if you have any questions on citations or whatnot, I can get those over to you in a couple of days. I pulled this together. We've been traveling a lot. We just came back from North Carolina, so didn't have a chance to really cite out everything. But I pretty much, through the podcast, I pretty much know some of this stuff by heart. And the podcast will start up in 2022 after the time of COVID. I kind of looked at some of the things that I really valued in my life, and saving the night was definitely one of them. Stars have done so much for me, and as someone who's an amateur astronomer, former president of the DVAA, and it seemed like a natural lead in. But I did learn something. I learned a lot in doing this podcast. So let's start off with some time travel, right? Let's start off with, let's go back to early days of 1900s. Pretend that you're in Paris, in the City of Lights. At that time, according to astrophysicist Brad Turner, who he came across some records from the French astronomer Guillaume Bigoudon, indicated that you could still feasibly see the Milky Way just out your window. You could see our home galaxy span from northeast to southwest in Paris. That's roughly 100 years ago, 100 years in time. And we've gone from possibly a sky that looks like this to a sky that looks much more like this for most people. It's pretty stunning how much things have changed, and stunning how good the skies were back then. I'm working my way through the Astronomical League's obsolete constellations list. One of these, I think, lists that doesn't get enough attention. And many of these constellations require a limiting magnitude of somewhere around 6 just to make out a large chunk of those stars, sometimes more. And by doing some of these great Astronomical League lists, you really gain a perspective on some of the things that we actually lost. So to that point, we do appear to be in the midst of a hockey stick-like curve shooting upward, unfortunately. This is spurred in part by, public policies that incentivize rapid conversion to LEDs, and also by cheapness of light fixtures and energy expenditure associated with them that would otherwise be too costly in an earlier time. So what? Who cares if we can't see the sky? It's a question I think everyone on here has had people ask, or maybe thought from in conversation you've had with other people, say family, friends. Anyone who's passionate about the night sky has probably had to field this question in some shape or form. You even hear this from amateur astronomers. You'd expect to have a little more skin in the game. But to be fair, we do our fair share to promote responsible practices, responsible policies. We tend to be, it tends to be a simple numbers game whereby we're just a tiny percentage of the total population, but boy, do we punch above our weight. So we're not sizable enough to sway public opinion en masse, but I think, we are making slow inroads. The problem is the pace. The pace and haphazard approach of LED installations has changed the sky brightness in very short order. We witnessed degradation right here. I look at my time here in Philadelphia. In the past 5 years, I've seen the area that I live in go from a high Bortle 7 to a borderline Bortle 9. So it brings me back to that initial question. Who really cares? Well, obviously I care, and I know you care. I assume that you care because you're watching me talk right now. I like walking around in the dark. There's something human about being able to turn down your sense of vision and turn up your sense of listening and touch. Nighttime brings out different functionalities and challenges for your brain. It also helps us appreciate our environment and see things that we would really never see. Sorry, I'm a little behind on my slides here. I took this photo right here from the York County Star Party. And there's something magical about being able to actually see nature on the other side of the day. So who really cares about this, right? Isn't it? This is just that common refute. Well, darkness breeds crime, and that's why we must light the night to infinity and beyond. Now, I'm not arguing that, or I'm not stating that we should put out all lights. I think lights are very useful. It helps us walk. It helps us be able to navigate areas. It helps us see what's coming down the street. It helps us in many ways. But we're talking about the excess use of light here. What if I were to tell you that crime actually occurs during the daytime? I mean, they're actually linked. Most crime studies appear to have an inconclusive link between light and crime reduction or crime increase. The positive studies appear to have commonly cite corresponding daytime reduction in crimes, often driven by perceived investment in an area. So if an area is redeveloped, they often see a daytime reduction as well. Negative studies show no change or even link street crime to evenly lighting to street crime spikes. There's also another study that came through because criminals do need light. And this one is from Vienna. They looked at, in the middle 20 teens, a LED conversion in the city of Vienna. And during that time, the study is emblematic of the crime studies we have. So the study found that lighting during that period, crime during the period of the LED conversion actually reduced. But crime in specific neighborhoods that had LED conversions actually had a high correlation between the new lighting and crime, say burglaries or robberies. So in one sense, it's saying that, hey, lighting actually deter crime. In the other sense, it's saying that lighting did nothing for crime. So maybe lighting isn't the right variable to assess this by. And here we see that we have the weakest link between any of the other studies that are going on in assessing artificial light. In fact, we keep trying to put up light and say that light is going to be some magic variable when we know through many studies that it's just not the strongest reducer of, or strongest correlative variable of crime. Well, that's all good to know, but I'm sure your friends and family still will probably be skeptical. And why? Why would they be? Well, for one, it turns out that light pollution really isn't the easiest pollution to fix. Darkness is scary. Darkness isn't rational. Fear isn't rational. Our fear of darkness is one part evolutionary and one part cultural. When you put those two together, we have countless illusions and metaphors that make night and darkness out to be bad, while light and daytime are always pure and safe. I would even bet that on this very show, and I heard it last week, you have countless times when someone says the phrase illuminate, enlighten, shine a light as a positive connotation of intellect or purpose, right? While dark or maybe shadowy is a more derogatory framing of an idea. So let's move on from crime. No one really likes talking about crime, so let's move on from there. Okay. Now, over in the health side, our understanding of health-related issues with artificial light at night gets us a bit closer to the real story. Here, the correlations are a bit easier to see. We can say directly that colors and brightness of levels of light we can say directly that colors and levels of brightness at night actually do affect human circadian rhythms. There appears to be a trend in the research directing us to recognize that artificial light levels may create long-term health problems. We have a study of biological rhythms that found infants born preterm discharged earlier when experienced darker nights than did a control group that were sitting in a 24/7 lit environment. The American Medical Association actually suggests that we have streetlights that are 3,000 Kelvin or below, which is what the IES has implemented as guidance across the nation. From the Journal of Hypertension Research, it's found that artificial light at night actually affected rat blood pressure patterns. Typically, blood pressure rises at night, but when exposed to artificial light at night, the pattern became unhinged, pointing out potential impacts of cardiovascular control of blood pressure. And from the American Heart Association, individuals who are regularly subjected to artificial light at night had greater risk of developing strokes. And then there's that Alzheimer's study that came out about 2 months ago, which looked to say that to areas and communities that had greater artificial light had a higher correlation to Alzheimer's. Well, okay. By now you can see that the initial definition of light pollution set out by David Crawford has expanded quite a bit, right? Including household objects. You can think of indicator lights, air freshener lights, clock lights, you name it. Everything in our bedroom environment has gotten dramatically brighter, but we still don't have a direct tie to say that this light is actually causing some of these illnesses, right? The Sphere, and due to this, we have issues like this. The Sphere, a popular new entertainment facility that was built in Las Vegas and came live last year, was looking to expand out to London, and they looked at Stratford, and they offered to buy all the residents of Stratford blackout curtains. So instead of simply being a good citizen and turning off the globe after a certain time, the company would rather elect to impose on others. And the onus of preventing light trespass appears to be solely on the recipient of the plight. It's not on the perpetrator themselves. Imagine other forms of pollution were like this. Let's go look at other forms of pollution like this, right? Noise ordinances. Instead of having noise ordinances, we just told people to thicken their walls. We didn't have water regulations. We told people to buy better filters. What if we didn't have air quality standards? We would just tell people to walk out the door with respirators, right? It makes no sense. So we covered crime and health, but in reality, beyond anything else, the very strongest data we have about light actually is the impact on our environment. And to this, there were two journals that looked to, actually, let me reset myself here a little bit. In that last slide, let me reset myself again. The decrease, what we're going to see here, Scott, relax. I'll be good here.
No problem.
So I'm going to show just some of the articles that we had that came through over the last year. And it's astounding the amount of research that's going and looking at how artificial light affects the natural ecosystem. In addition to this slide, there's a decrease in melatonin levels in birds, which reduces their cognizant abilities when they're in artificial light environments. Artificial light in lakes, ponds, rivers reorder the culture of life living in that waterway. Artificial light deters traditional nocturnal animals from hunting in that area. Artificial light enables both nocturnal and diurnal daytime predators to extend their hunting to the point of exhaustion. Artificial light thickens leaves in trees, thereby making them hard to consume by insects, and reduces soil aeration by earthworms. Artificial light traps moths and other insects that orient using lunar or star light. Now, it could be fair to say that artificial light on its own isn't the cause of an insect apocalypse that we're currently living through, but it's definitely one of the driving forces involved. So light pollution isn't all about astronomers. And this was something that I had to learn when coming out of COVID, when I was getting back into kind of seeing what mattered to me. And I looked at light and light pollution. And I started realizing this is actually much more of an ecological issue. And us astronomers, we're not really affected that much by, outside of having professional facilities have data collection. Obviously, that's a costly issue, but they're not being imposed in a way that the environment is being imposed. So artificial light at night is a real pollutant. And last year we saw two journals, Science and the Philosophical Translation of Royal Society B, dedicate editions just to light pollution. And I just want to bring up, let's see if I can bring up this, this definition somewhere in there. Okay. So this definition here, I like to bring this up because this really helps. I think if we had if we thought of light as being an actual pollutant, we'd make much better decisions. And this helps build that framework. So what they did in the Philosophical Transactions of the Royal Society B, one of the articles, the lead article, outlined a framework for why they considered light pollution to be an actual pollutant. It's a form, matter, or energy that are produced by human activity, are present in the environment, concentrations that alter natural ones, and may cause or may reasonably cause harm to humans, the environment, and or other goods of nature, which is the usual scientific and legal practice considering what a pollutant is. So to summarize, crime and light don't appear to have definitive links at this time. Health and light appear to have potential links, maybe potentially strong links, but that said, there's much more research that really needs to tease out what's going on here. We know circadian rhythms are affected by light, color, and brightness. This in turn affects melatonin. We may or may not influence a multitude of ailments via melatonin. This affectation of melatonin may or may not affect or influence a multitude of ailments. However, we do know that much more research still needs to be applied here to understand what's really going on. On the environmental impact of light, however, it's pretty clear, it's well documented that light pollution changes the physical environment. And for some reason, this message just isn't getting out enough yet. So I'll finish my talk out with a little anecdote. And many cultures have calendars, heritage, or stories that showcase the night sky. The night sky, after all, is the largest and cheapest anthropological museum that we have in this world.
Hmm.
There are many tales I could tell you, but this one I'd like you to ponder. In the antebellum South, seeing the sky was much more than just a nicety. It was a matter of life or death for runaway slaves. Songs like Follow the Drinking Gourd, which is code for the Big Dipper, helped guide folks to freedom via the Underground Railroad. If that doesn't help explain the magnitude and power of the night sky's shared heritage, then I'm not really sure what does. So I want to thank you, Scott, for allowing me to jump on here, and
Yeah,
thank you for the
thank
great
you
show.
so much, Bill. That was excellent. That was excellent. You know, we cannot learn too much about the benefits of a dark sky, and we waste so much money with just bad lighting. I had a friend that was we were doing astronomy outreach, and somebody came up and complained about how much money was the billions of dollars that were being spent on, wasted on science programs, flying to other planets or whatever, and he and another group of friends, I'll have to maybe get this information for you, but they had calculated how many billions of dollars that we would save just by redirecting light or turning off lights. Okay. With that, we could feed the world. So something as simple as that. If there was actually a program to turn off lights and the money that you saved, you gave it to people to eat, then, we could have our science and eat too. So there you go.
Scott, if I can just jump in real fast. I think one of the things too is that people get afraid when they hear about dark sky advocates or starry night advocates that we're going to take away the lights. And, that's simply not the case.
They're afraid of the dark. Yeah.
Well, people are afraid of the dark, but I really think if you look through the framework that if you make your decisions based on the fact like you would do for your yard or for your house, or pesticides or herbicides or any kind of chemical pollutant that you already recognize, if you looked at light from the same framework, you would make really good decisions, and you would put in really good fixtures in just your own property there. And it would help guide, you would have good, effective lighting, and you would also have responsible lighting.
Right. Yep. Well, great. I hope you come back on sometime. I hope that people that got that link for your podcast will share it, and keep up the great work. Thanks a lot.
Thank you.
Thanks a lot. Okay. All right. Did you want to finish up anything, Don, with
No. The AL Live was canceled last Friday because Barbara Harrison was ill. So we're looking to get that back in the schedule. Don't have a scheduled date yet.
Oh, very good. Very good. Yeah. Sometimes things like that do happen. So
yeah, people get sick. It happens.
We keep on going on.
Yep.
Speaking of things that keep on going on, we've got David Eicher, who has been painting his house nonstop. It's amazing he doesn't have like paint all over him, because after a while, I mean, I do on me when I'm painting. So I'm just kind of a messy guy.
I'm what they call an unskilled painter, Scott. So I'm getting most of the paint on the walls, but a little bit on me.
A little bit on you too.
Yep.
Okay. Well, that's good. Yeah. It washes off, most of the
that's
time.
right.
Most of the time.
Yep, indeed.
Well, great. Well, I mean, what we can see here at this little window of your house, it actually looks awesome. So I would say,
Yeah.
good job.
Well, I'll give you a tour in another 6 or 8 weeks. It'll be all done.
Okay, that sounds good. Well, David, thank you very much for coming on. And this time it is NGC 2685. Is that right?
Indeed, and light pollution is so important. That was really good, that talk, or we will never see after another few generations galaxies like this. And of course, with so much light, if you look at a light pollution map of the United States now, or many other places, countries, it's really distressing to see the light that is going out into lighting up the solar system, which does a lot of good for electric companies, but doesn't really do much of anything on Earth here. So let's hope in many ways we'll have more intelligent lighting in the future, or astronomy is going to be tougher and tougher to do. But
Well,
while
we'll
we
have
can
to-
see them, galaxies are among the favorite things that I have to see. And when I'm not fooling around with painting or with Astronomy Magazine, I will share my screen, share the right thing, see if I can start this slideshow somewhere, and talk about another object. And I talked about the eclipse from Easter Island last time, but now I'm back to deep sky objects. And I'm not going to talk about Centaurus A, but as Scott said, I will talk about NGC 2685 tonight briefly, which is often called the Helix Galaxy. It's an odd galaxy. It's a lenticular galaxy, which of course Hubble thought of a little bit originally, but then Gerard de Vaucouleurs really put into a precise format of classification when he came along in the late 1950s to kind of complete the modernization, if you will, of the classification of galaxies. It's not only a lens-shaped galaxy, lenticular is a fancy word for lens-shaped, but it's a polar ring galaxy, which is truly a rare kind of galaxy that shows a polar ring of material perpendicularly to the galaxy's main disk. And Scott, this is a happy coincidence for once. I'm working my way down through hundreds of objects from north to south. This is one that intersected with your theme really well, because of course, we believe what creates polar ring galaxies is interaction with other nearby galaxies in the distant past in a very peculiar way. And this creates, of course, streams of stars that are orbiting the galactic center of this galaxy. So this fits in right with your theme for once here. And it's also a Seyfert galaxy. Carl Seyfert in Nashville produced back in the day when there were all these high energy so-called active galactic nuclei were mysteries. And Seyfert galaxies had energetic nuclei that were unusual and not well understood for about 30 years. And now we know, of course, all these phenomena of so-called active galaxies are black holes in the centers of these galaxies that are viewed with different geometries. So that's what we ended up with Carl Seyfert and many other kinds of galaxies. This object is about 42 million light years away. It's in Ursa Major and is at about half the size, the disk of this galaxy, of the Milky Way, the bright disk of the galaxy, about 50,000 light years. And it's a little brighter than 11th magnitude and about 4 by 2 and a fraction arc minutes across. So it's relatively small. It's moderately bright, not super bright, but it's easily within reach of moderate and larger scopes, of course, and even small scopes under a dark moonless sky if we can get away from those lights. It's a rare galaxy, as I mentioned, in that lenticulars are fairly unusual as well, and really rare as a polar ring galaxy, of which there are only a fairly small number of a few dozens of really good, bright examples of those. It's a great target for observers and imagers. So I suggest to go out and shoot stuff like this. And also observe it. I'm a live photon guy. I had one season of astro imaging and then gave up when it became much easier publishing my first little magazine to go out to the mailbox and get images from really good astrophotographers. Here's a section of Ron Stoyan's atlas that shows where the Helix galaxy is, just below the bowl of the Big Dipper, or that gourd of the Civil War era of slaves moving, ex-slaves moving northward, following the drinking gourd. And you can see it here. It's also classed as ARP 336 because of its active nature. And there, of course, a field of many galaxies in Ursa Major that we can see. Mark Hansen produced this really nice image of NGC 2685, and you can see the polar ring is a little tough to see here, but you can see the main axis, you know, going from lower left to upper right, and then you can most easily see the dust lanes in front of, just below the nucleus of the galaxy, of the polar ring, and also material that's sort of that lighter cyan or blue color. And the interaction of those stellar streams producing a new generation of younger blue stars, which normally probably wouldn't be happening if not for the tidal forces that are acting outside of this galaxy center. Here's a little bit closer, better view with the Gemini North Telescope. Wow. That's a little bit of an aperture advantage here, and you can see the dust lanes pretty well in front of the left side of this galaxy, on the left side of the nucleus. And that's the polar ring of stuff that's not exactly dead on to us, but it's a little bit leftward there, as well as the main body of the galaxy. And if you have the Gemini North Telescope, you can see some really nice background galaxies as well, but that's getting to be really faint stuff here in this field. So that's it. It's the Helix galaxy is my example this time. And the November issue of Astronomy has a little bit about the sun. It's kind of a status report on what we know of the most important star, you could say, to us. Of course, we've just passed now solar maximum, but there's still a lot of activity with our star right now, and we're going to be going over the next few years to slightly decreasing solar activity in that 11-year cycle. We've also got a report on the last Starmus Festival that a number of us attended in Slovakia, and some other stories as well. And we will be having another Starmus Festival coming up next spring if you want to join us in La Palma, which is off the northwestern edge of Africa, the Canary Islands. This is a wonderful place to go. This is the largest telescope in the world here, which edges out the Keck in Hawaii, 10.4 meter. And we'll be having this late in April, the Starmus Festival, with a lot of Nobel Prize winners and astronaut explorers and astronomers and other scientists, and some rock and roll as well. So we hope that you'll join us in the Canaries for the next Starmus. Scott, that's all I have. I will end my slideshow.
All right.
And move on and end that share. And thank you, as always, for having me on. It's always a pleasure to see everyone here. And I always enjoy it. And I'll go back to painting walls pretty soon here.
And we're not in danger of running out of deep sky objects for you to talk about, are we?
Well, the initial list that I made of going through a couple of atlases, which was a fun exercise for a few days, I came up with, I think there are about 400 more to go. So we're not going to run out anytime soon. I think it was about 8.5 years worth when we started this. So I think long before 8.5 years, you'll say, Dave, I'm really tired of you. We'll see you later. And we won't even make the 400, I think. But there are quite a few to go yet. We're in Ursa Major. We're working our way from the North Celestial Pole southward. And remember that our old pal, Scott and David, Bart Bach, you know, used to joke many years ago, David, when you were the one who introduced me to him, David, you know, all the good stuff is in the Southern Hemisphere. He wasn't exaggerating that much with that statement, you know, that joke he used to like to make.
Absolutely.
That's pretty much true.
I mean, just one visit down there in a dark sky site, that's, you will absolutely agree. So
on Easter Island, we had about an hour before seeing the comet when it was in the morning sky. And
Mhm.
boy, you know, an hour with the southern Milky Way, the Magellanic Clouds. And I always like to see the Orion Nebula, okay, and look over then and see the Carina Nebula that's 3 times larger and 4 times brighter. And you think, holy cow, that's a
Right.
nebula, you know,
Yep.
wow. You know, love the Orion Nebula, but my God, the Carina Nebula is something
Carina
to see.
Nebula is
You want to do
ginormous.
that
That's true.
as an observer at least once in your life, the Southern Hemisphere, no doubt about it.
Now, David, did you see the Magellanic Clouds when you were at Easter Island? Or-
Yes, they were up in the early morning sky,
Wow.
and we had a beautifully dark sky. Went out to the eclipse site and then saw a brief eclipse. It was an annular eclipse this time, about 22 days ago. I'm sorry, 27 days ago, I think it was now.
Mhm.
And it lasted about 4 minutes and change, you know, a decent, but it was an annular, you know, which isn't quite, you know, as exciting as a total. But we had a beautiful hour or so that morning with the southern sky with Carina and Crux and the Magellanic Clouds and the whole rest of that song. And then the comet and then the eclipse. So that was a triple play
Yeah.
observational day that was hard to beat.
And you're surrounded by all of these stone faces and stuff. So,
You know, the moai, the statuary there, most of them I think were made between 1250 and 1500 AD.
Okay.
You know, and these were guys who didn't have a lot to do on this island. I mean, this is a long way from anywhere, this small island, Easter Island. No kidding, you know.
Right.
Even now, it was a 5.5 hour flight westward from Santiago. Back in the day, you were a long way from anywhere. So you had fishing and making statues. And I was blown away, Scott. I knew there were quite a few of these, and they've restored and uprighted many of them, you know. But there are nearly 900 of these statues on Easter Island. It's astonishing. You know, so
Yeah.
they are all over the place.
Well, yeah, I can imagine, you know, the isolation and all the rest of it. But, you know, maybe there was a lot more to it than just chiseling out another head. You know,
When I heard about this trip, you know, I assumed, you know, we'd be taking a Cessna to fly out to Easter Island here. We had a 787. There were enough people who wanted to see the eclipse.
Oh, wow.
Not the
Okay.
largest commercial plane you normally easily get. We landed at the airstrip on Easter Island, and the 787 came to a stop, Scott, with about 50 yards to the end of this runway was about the whole length of the island. You know, okay, so fortunately we stopped, we got off, we had a good experience.
Sure. That's good. All right. Well, I'll have to try to get out there sometime. A lot of my friends have visited Easter Island for various astronomical adventures. So it's got to be a cool spot to go to.
It's really something to see. I think you could see the whole island, honestly, in about 3 days. We were there for about 4 and a fraction. But it is an amazing place to see once, at least in your life. Yeah.
Very cool. Very cool. Well, if you guys missed David's program, you can just search for the 159th Global Star Party, and he'll tell you all about what it's like to be at Easter Island for an annular eclipse. So, okay. Thanks, David.
Thank you, Scott.
All right. Okay. So our next presentation will be with Kevin Schindler. He's the prime historian at Lowell Observatory. He's a great guy, incredibly knowledgeable, and together with Ian McLennan. And I don't know how they want to make their presentation today, but I think it's cool that they're together tonight to talk about the new Astronomy Discovery Center that's being established, or that has been established at Lowell Observatory. I know it's been quite a while in the making, maybe years more in the planning. But you know, I think that when we get there on November 16th for the ribbon cutting ceremony, we're going to be duly blown away. So, Kevin, I'll bring you on. And do you want to get started first and then bring on Ian, or how do you want to do this?
Actually, we'll both go at the same time. We're going to just kind of chat together.
Okay. All right. Well, let me take myself off and bring Ian on. And there we go. So Ian McLennan is a consultant for all kinds of science installations, and he's been doing it for a long time. He's extremely well known in the planetarium community. But if there's any kind of, it seems like any kind of observatory, any kind of science center, especially one for educational outreach, or any planetarium installation going on, if Ian's not directly involved in it, he knows all about it. So, and I know that he was very involved with the Lowell project. So I'll turn it over to you guys.
Thanks, Scott. And it's really great to join you guys again. I feel honored to be with a bunch of this all-star cast, and what you and David have been doing. I'm looking forward to the 912th star party when we get caught up with Dave Eicher's deep sky objects. So
Well, have me on life support or something, as I do it.
I've got it on my calendar.
Okay, all right.
Well, really, thanks for having us on here. And this is something we're pretty excited to talk about, not just as for me, a homer of Lowell Observatory who loves the place, but for somebody who really appreciates astronomy outreach. And one of the things that David Levy talks about a lot is the inspiration of the cosmos. And,
Yes.
It's not just looking at things and how it makes us feel and wanting to go forward and do something good and this inspiration to all we feel. And that's really this new Astronomy Discovery Center. And it's really great that Ian can be here with me, because Ian is just a legend in the astronomy community and has helped create so many unique facilities around the world. And I don't know how many unique facilities you can have, but this Astronomy Discovery Center is certainly unique because it uses state-of-the-art technology and programming techniques. And then, by the way, it's affiliated with an observatory that's 130 years old with a long heritage of research and education. So it's really pretty unique. And we're really excited to be talking about it and opening it soon. I think among staff outside of our Chief Operating Officer, Amanda Bosch, outside of her office, she has a daily countdown, X days till the opening. And you get a sense of excitement and pure terror as the days go by that, this is happening. Oh, this is happening. Oh, this is happening. But it's, on a smaller scale, but, when we flew to the moon, 400,000 people were involved with making it happen. And again, a smaller scale thing, but you look at the number and diversity of people and organizations that make a project like this happen, from planning to designing and building, fundraising, promoting. It's staggering. And I love it when, you find out what your team is made of when things are getting tight. Like when the observatory built our Lowell Discovery Telescope years ago, they were figuring the secondary mirror and it shattered. And that was a moment of excitement for everybody on staff. But everybody pulled together and made the most of it and ended up with a product that is unsurpassed. So I think the same with this. You have great people. Ian and his team have done so much of this to have their expertise. Lowell has a lot of smart people, but not a lot of people who've designed something to this magnitude. So it's really cool for us to be able to talk about it. So
I think, Kevin, it's worth mentioning perhaps that one of the aspects of this that's really quite exciting and rewarding is that this relates back to the very beginning of Lowell Observatory, where Percival Lowell, the founder of the observatory in the late 1800s, dictated that the observatory would always be a center of leading edge research, but in equal measure, public education. And because of that, the observatory has excelled in both areas. And Kevin will talk about some of the discoveries that have been made at Lowell Observatory, but those have been twinned with the impetus to reach out to the general public.
And that's a great lead in, Ian. And in fact, I'm hoping this slide is showing. Scott, maybe you can confirm with Percival Lowell.
Yes.
Okay, so when Lowell founded the observatory, he wanted to do scientific research, but he said, what's the point of doing it unless we share it with people and excite and inspire them, much as David Levy has done his entire career. And so, Lowell wrote, we want to make people co-discoverers, not just do it ourselves, but we want them to feel the excitement of looking up at the sky and feeling like they've discovered something themselves. We can all get jaded after looking at Saturn or Jupiter so many times, although I don't think anybody in this group does. But we want everybody to make that discovery. The first time you see something like that, maybe you didn't discover it for humankind, but you're discovering it for yourself. And to feel that connection with the cosmos is just really special. And this is something that Percival Lowell, said from the beginning, this is what this observatory is going to be. So through the years, this outreach has been a critical part of what we do. And from in the beginnings in 1894, 18 years before Arizona was a state, observatory was doing research, and you could see ads in the local newspaper. Come on up to the observatory on Saturday night and look through the big telescope, the 24-inch Clark, which is shown here. And through the years, that interest expanded. When Clyde Tombaugh discovered Pluto in 1930, that certainly spurred a lot of interest in visiting the observatory. As the years went on, the visitation grew. We had a visitor center that was in a small room, the so-called rotunda. But then in the 1980s, we got a new sole trustee, Bill Putnam, who's a grandnephew of our founder. And he said, what Percival Lowell said, we want to make this accessible to everybody. We're going to really expand our public programs. And so we built a visitor center completely dedicated to doing this. And this new visitor center would allow us to triple our attendance, so we could get maybe 60 to 70,000 visitors. Who knew? Maybe we could get that many. So we planned for that, and had this unique blend of astronomy programming, the opportunity to look through classic telescopes like this refractor, the stories of discovery like of Pluto, plus the opportunity to interact with scientists, who in general are real people too, and really great to talk to. And so, it's a great combination of outreach and science, communicating science. That's what we do. And so this kept going along. And then again, Pluto reared its ugly head, as it were, when we had the New Horizons flyby in 2015. Again, that spurred a lot of interest from people to come to the observatory and see the heritage of Pluto, the home of Pluto, where it was discovered. And so many discoveries related to it have been made. And our attendance started really jumping up to over 105,000 visitors a year. And that's a facility that was designed to accommodate 60 to 70,000. And so our leadership started thinking that, we've hit a tipping point. We can either keep doing what we've done and watch a lot of unhappy people circle the parking lot a couple times and leave because they can't find a parking spot, or stand in a telescope line that takes an hour and a half to get to the eyepiece when it's 25 degrees on a cold winter night. Or we can expand, and not only expand to where we have more things for people to do, but also make it the best quality. If we're going to do it, let's do it right. And thus began this idea, right after New Horizons, really 2015, this idea of expanding the visitor experience. So it started with, kind of an immediate need. We have a lot of people, they're waiting in long lines. We need more telescopes. And so phase one was, let's do a quote unquote quick fix and build this new observing plaza, the Giovanni Open Deck Observatory, that has 6 telescopes. 4 of them are eyepiece, and 2 of them have monitors to where we can look at a variety of things on any given night in different ways, through eyepieces, through monitors, and really teach and inspire people. And so this opened in the fall of 2019, just in time for COVID to hit the next spring. So but we got it open, and it really helped us with our crowd control, and just giving people more things to do and more inspiring opportunities. And so as this was happening, then the goal was, okay, this is kind of what our director, Jeff Hall, calls the appetizer. The main course is going to be this new visitor facility. It's not going to be a modified version of what we have. It's a brand new facility. We're essentially starting from scratch. We're not going to try to make what we had a little better. We're going to start from scratch. We're going to bring in people like Ian and his team, and talk to fundraisers and talk to the community, and make sure we're creating something that goes beyond Lowell Observatory. It's a crown jewel for Flagstaff, for Arizona, and for the field of astronomy. And so thus was formed this idea of an Astronomy Discovery Center. We decided not just a visitor center, but a science center, essentially, because studies show that especially kids learn a lot more from those interactive, informal science opportunities than in the classroom quite often. So we decided to build this this new facility, and maybe Ian, you can comment on, like, when you came on board and what your thoughts were about this.
Well, it might be useful just to reflect on the fact that the initial idea was to build a small planetarium. And it was an interesting idea. Michael West, with whom I worked in Hawaii, came back when he started with Lowell Observatory and talked to Samantha Gorney, and suggested that we might build a small planetarium at the Lowell Observatory, and that would take care of the visitor needs for public exhibition in astronomy. And Bill Peters and my partner in consulting, he and I ran various workshops with the Lowell team. And eventually the idea expanded, and this wasn't a result of any agenda, nobody's agenda. This just grew organically as we began to realize that there were opportunities as well as obligations to right-size this thing if we were going to be dealing with an awful lot of people. So eventually, over time, this small planetarium grew into a major astronomy discovery center with many of the elements of a planetarium, but with much expanded.
And it really did. And it grew into a 40,000 square foot, 3-story high facility that, to me, it really has a little bit of everything for our typical visitor. Well, not just our typical visitor, any visitor, whether you have a really strong interest in astronomy, a passing interest, or you've never looked at the stars. There's something for people of all ages, because one of the goals at Lowell is to make astronomy available to everybody. It doesn't matter your gender, your race, whatever. We want to try to make it accessible to everybody. And so that's how this project came about. And so what we'd like to do is kind of do a walkthrough of the we'll just say ADC, Astronomy Discovery Center. And I'm going to show, as Ian and I talk, we'll show a combination of drawings as well as pictures taken over the last few days. And to give you an idea of timeline, our last open day of our current Steele Visitor Center is October 31st, so just a couple days away. And we're going to maintain that facility not as a visitor center, but as the Steele Learning Center, so a place where we can do summer camps and science conferences and that sort of thing. And then the new ADC, officially, the groundbreaking is on November 16th, but will be open to the public for a few days before that. But then starting even before that, we have some sort of soft openings for donors and family members and so on. And so some of the things I show you, some of these pictures are just a couple days old, but they've changed. a lot over the last couple of days because the final touches are being put on. So let's just go through this as you walk into the center. This is the main entrance, and there's a brand new visitor parking lot. So if you've been to Lowell and the next time you come up, you're not going to park in the same spot. It's the new parking lot. You kind of go around the old one. And this parking lot is much larger. The old one had something like 60 parking spots, and this one has 260 or something to that effect. And so it allows for really increased growth. When you enter, you'll see on the left side, that's a Mars rover, the Perseverance, kind of a model of it. And the idea is, this is a science center, but it's Lowell Observatory, so we want it to feel like Lowell and represent how we're serious about our science, but also, we have fun doing it. And so this rover here, you see three kind of smallish green blobs. Those are Martians, kind of in reference to our founder Percival Lowell, who believes there is intelligent life on Mars. That's not necessarily what he thought it looked like or anything, but it kind of connects that heritage of the observatory. So as we go inside, oops, I forgot, I've got another view. This was taken just last week. This is a view from the other side. So you go in on ground floor, and there's 3 levels. You go up a level, and then you come out. Here are the back doors, and you notice the glow along the sidewalk. We don't have any lights along there. Those are glow stones that glow in the dark, but they don't affect your night vision, and so you can leave the building and transition into dark skies as you walk. Kind of where our view is where the Giovanni Open Deck Observatory is.
Those are phosphorescent stones, and they're absolutely beautiful. It's quite an exquisite thing to be walking over those, and some of the shapes are galactic and other star forms as well. It's quite magical.
It's cool.
And I think it's to me, this represents all the thought that went into this. There's so many details, and we're in an observatory. How do we make it safe for people? Well, we don't need lights to go outside. We have these glow stones. There's just a lot of really insightful planning that went into this. So we'll go back to the front again on entry, and as you come in to the right, there's a cafe, and it can seat it's got about 40 seats or so. And we just signed the contract with a local restaurant, Jitters. They're going to supply, sandwiches and soups and drinks and stuff like that. And so in the summertime, you can sit on the patio out front. And in the wintertime, there's a nice fireplace in here to make it for a great atmosphere. And then on the other side is our gift shop. And the gift shop, this is actually what it looks like right now. As soon as we close the other visitor center in a couple days, they're going to move all the stock over and completely get this stocked up. So this is pretty close to what it looks like right now. And then you go toward as you go toward the main part of the building, you enter kind of the main gathering place. And this is just such a cool thing. It's called the Origins Gallery, and that you kind of see that spiral feature in the middle with all the different lights. That kind of demonstrates the origins of life on Earth, from the earliest molecules, the Big Bang at the top, and the earliest molecules, to eventually the development of life. And there's at the bottom, there's a display that has different features representing life on Earth. And Ian, I'll jump in anytime. Otherwise, I'll just keep going on and talking about some of the other highlights.
Okay, one of the things that I should mention is that the exhibition design has been done by a company called Key Space Design, and it's headed by Juan Tanis, who's a brilliant designer with Mexican flair in his background, but he brings such a wonderful design aesthetic to his work, and he's done a superlative job with this installation and this design.
up till last week, this sculpture had been up, but the lights hadn't been on yet. And then
Hmm.
last week I saw it with the lights on, and it just comes alive. It's such a different feel. And pictures, of course, don't do it justice, but you get kind of the idea of what's happening. So this is kind of a central gathering area in the main part of the observatory, kind of the hub of the visitor center. So if you again continue on the left side of the building, there's two exhibit areas. The first one is called the Orbit's Curiosity Zone. And one of the things that was important, I think, for Samantha Christensen, who's kind of headed the exhibits in here and programming, was making sure we have something for everybody. In the past, we had an exhibit hall, but it wasn't really designed for younger kids. And we have a lot of young visitors, like, under 8 years old. So this Orbis Curiosity Zone is designed specifically for up to 8 years old. Although I'll have to say, in walking through it last week and going down the slide and playing with some of the stuff, I noticed a lot of us so-called adult staff, they really had a good time with it. So it's something designed for the kids, but it's really stunning. This is a picture I took last week. We have the planets hanging from the ceiling to scale, and then there's just everything is tactile in here. There's only one monitor, which I'll show in a second, but everything is something you touch. I mean, it's like kids go here, they're playing, but they're learning stuff. It's everything is educational and ties in with astronomy. Kind of leading them through the way is Marsy, this little character in the middle, and to the right is Pluie, because of Lowell's connection with Mars and Pluto. Those are characters that, they're going to be kind of leading kids through their experience. And we even have like stuffed animals that are going to be in the gift shop, Marcy and Pluie, and this lighthearted way of doing science that shows that science is fun. It's fun to learn.
Yeah, there's a cuteness factor there too, but it belies the fact that the Lowell astronomers paid a huge amount of attention to every scientific detail that was incorporated within the exhibition design. It's really quite a remarkable balance.
And I think that's another comment on getting a whole team together, because the astronomers certainly can share their knowledge and make sure things are accurate, but they don't design exhibits. That's what you guys do, Ian and Juan and Cruz. And so getting all the different experts in their field together was really critical to making this thing work so well. This one has been a staff favorite already. This one, you launch a rocket. So this in the middle, there's this little, or right here on the right, there's this little lever you pull a few times to pump up the air pressure, and then you can move the launcher to different angles and try to get the rocket through circles when it launches. And it makes you think about what it takes to fly in space, and thinking about changing trajectory and speed and things like that. So again, it's all different ways of just having fun while learning. Oh, let me go back. I forgot to mention, right in the middle here to the right, I think you can see my cursor. That's the only monitor in here, and it's an infrared detector. So as you walk up, you can see yourself walking in infrared. So blues and oranges and reds and such. So it really captures, your attention when you see it. And then right next to this hall is the Stardust Lab. And this is kind of a traditional science center, but again, very tactile. Like to the right, you see this picture of Percival Lowell and a picture of Mars. Well, that's actually all 3D. So you can touch Percival Lowell and feel the contours of space, but then also the canals that he thought were on Mars, those are depicted here. And so that's how this exhibit hall is. There's just about every sense you use here. There's even an exhibit about smell, the smells of space. And so it's, again, different ways of experience astronomy and becoming inspired about astronomy. So this is on one side of the main floor. the other side is something that Ian has just masterfully brought together. This is from upstairs. This is the Lowell Universe Theater from the top. There are about 180 seats here, and down in the front there's a stage. And that looks all very nice, good and well, but this is an image from last week with they're practicing one of the shows we're doing. The screen is 25 feet tall. And how's it measure, around 160 degrees or something like that?
160 degree. It's a wraparound, almost cinerama style LED screen that surrounds the audience. It's just a remarkable facility, and the LED screens are so bright and crisp that the imagery is stunning. It's just absolutely stunning.
And you can kind of see the screen. I'm outlining it here. It's distorted because of our view, but this is it. So that's 25 feet tall there. And then it comes around. And then there's another screen up here.
Overhead screen, yes, for overhead effects and sky effects and ancillary imagery, and it just enhances the whole thing. And this replaces the idea of a traditional planetarium, because it has planetarium programming capability built into it. But it is a different type of theater format altogether that envelops the audience in a one-way seating.
And this is an example that, like you were saying, Ian, we could play the Super Bowl on there or the World Series or something if you can get the right format. But the programs we do, they're not just showing a video, live interaction. Some of the programs have actors. This is them practicing this one. Our first program that we created is about imagination and the critical role of imagination in science. And
this takes advantage of one of Lowell's strengths historically, and that has been its staff has been trained to be presenters, and so we're tapping into that. So these will be live shows augmented by this amazing 3D LED experience.
Yeah. So this is just one of the theaters, though. There's another one we'll see toward the end here. So that was on the first level. We go up to the second level, and there's something called the Great Planetary Hall, which is a big room with supersized images of planets on the walls, and that'll be a great place for doing programs and luncheons and weddings and breakout sessions for science conferences. And then it empties out onto the main campus to the Giovanni Open Deck Observatory. And then we get up to the upper level, and I'm skipping a couple things, but but getting the highlights. We get to the upper level, and you come out onto this terrace, which this was going to be the original top of the building, right, Ian?
Yes.
And the idea was this was going to be, as Ian said, this project started with an idea of doing a planetarium. And so the Universe Theater kind of takes care of the components of the traditional planetarium. But then on top here, we have another kind of quasi-planetarium. This is the entryway to this terrace. And then this was the original height, but we added another 8 feet. So you'd be just at the tree line rather than having your view blocked. And this is this theater up there. These are the seats being installed 2 weeks ago. These seats, notice these aren't just seats. There's all this wiring. These seats are heated. So this is another adaptation of the planetarium concept, except you're not sitting, these seats tip back, you look up, you're not looking at a ceiling with stars projected, you're looking at the real dark skies of Flagstaff.
This is one of the most exciting things I think I've ever been involved in. This is a real planetarium with planetarium technology built into it, but with heated seats. And instead of a dome screen above you, it's the real sky. And it's going to be absolutely exciting and thrilling and a groundbreaker. Although this is going to be a game changer.
And it's stunning because it takes advantage of Flagstaff's famously dark skies. During the daytime, the views in here of the surrounding landscape are just phenomenal. From seeing the different buildings of the observatory bird's eye view to seeing all these cinder cones on the horizon. But then at nighttime, to be able to have a 360-degree horizon essentially. And, like in the planetarium, we have somebody that maybe is pointing out the Orion Nebula, for instance. And then what's neat about this is the screen that comes up, and we can get a close-up view of the Orion Nebula as they're sitting looking at Orion in the sky. And then later on, when they're done, they can then go to our telescopes and see this close up with their own eye. And so it has this ability to really embrace the night sky and see it in so many different ways. And I agree, Ian. I mean, for me, this is the coolest part of the ADC. Is I think because it's so stunning. I mean, the views are amazing, and to be able to do a program like this outside, and
it pays homage to the history of the planetarium, which is just exactly 100 years old this year. But historically, it pays homage to that. But it also pays homage to the real night sky, which is a Lowell tradition, and so it's a wonderful marriage of two historical aspects.
And Ian, just to clarify, you weren't there for the first planetarium, right? I just wanted to make sure we got the date right on that.
Yeah, thanks, Kevin. I'll get you back for that one.
So this is just kind of a basic introduction to it, but it really is stunning, and we've had so many people viewing it, previewing it, and we've had a lot of media that are covering the construction, and that, like Ian said, there's just not anything like it. It's taking advanced technology, marrying with a research facility that also is an outreach facility, and it's just a unique combination. And so whatever you're interested in astronomy, I think you're going to find, something here that's really enjoyable and inspiring. And, I can't wait to have the Daves up there and Scott. Ian is so familiar with this because he's been such a leader in making this happen. But having all of you others up there for opening day and, seeing pictures, it's like seeing pictures of the Grand Canyon. And then you see it in person. It's stunning. And I'm really looking forward to that, to seeing not only kids going into the exhibit area and the look on their faces, but to see people like you guys who have been doing astronomy a good part of your lives, and to see how we now present that to the public. And by the way, as kind of a final note, I guess, when we built the Steel Visitor Center, we had no idea what attendance could be. And the same thing with this. We don't know what the maximum, what we'll top out on in attendance, but we want to be ready for the future in case astrotourism, as the current trend is, continues to grow. And so one of the forward-thinking parts of this is infrastructure was put in behind the two exhibit halls to where down the road, if we do find the need to expand, we can just remove those walls, and the hardware for electricity and everything is there. So it's already in place.
That's great.
And with our land, we can also, as we need to build more parking areas and stuff like that, we have the capacity to continue growing as needed. And so that, I think, is really great for the future.
And this will be a contribution to the advancement of astrotourism in Arizona and beyond.
Yeah,
Absolutely. Absolutely. I think this is one of the crown jewels of astronomy outreach and astrotourism in the United States. It's really, stupendous what you guys have put together. And I can't wait to sit back in one of those heated seats and look at the sky and have this kind of planetarium experience. I think it's going to be a lot of fun. We got a question. Lori is watching on Facebook, and she is wondering, when is everything going to be open? I know that there's the ribbon cutting ceremony on November 16th, but there's some other aspects like the 160-degree screen and this kind of thing. When will everything be ready to go?
It's all going to be ready on November 13th. That's kind of a soft opening. So 13th,
okay.
yeah, so 13th, 14th, and 15th, it's all ready. And then
It's
the
all-
16th is just the big
that's great.
celebration. Yeah.
Yeah,
And we're doing
so
some,
Lori, you need to beat us out there. So
Yes.
November 16th, ribbon cutting ceremony. I know that I think that you can become a member of this Astronomy Discovery Center and get in a day or two early, which is great.
A member.
in fact, we have member days before the 13th that current members can sign up to see it even earlier than that. We're starting to do kind of previews for like contractors. I think are our first open house in November 2nd or 3rd, and then every few days we're doing something else for a couple days of members, some nights for donors, and so on. So the first public night is the 13th, but depending on if you're a member, you might be able to come earlier.
And that's a member of Lowell Observatory, yes.
Right. Yeah.
Now, you might have mentioned Marley or the Marley family. What got them really inspired to put the endowment or the contribution to make this happen?
Well, the Marley Foundation has certainly contributed to a lot of public things in Arizona. The Phoenix Zoo, for instance, they're a big supporter of the Phoenix Zoo, and beyond that. Ian, maybe you can talk about this a little bit more, but I know that some of our leadership, Jeff Hall and Lisa Actor and others, went to talk to the Marley Foundation, and they saw the value of this, again, not just to Lowell Observatory or Flagstaff, but all of Arizona, as this would be a real boon to astrotourism and inspiration in general. And so they saw the value of this, and the money they gave was the largest donation they had ever made to any effort.
I think it's significant that there are over 700 donors to this project, everything from $20 million down to a few hundred. And the Marley Foundation is by far the largest single donation. But Lisa Actor, who was head of philanthropy and headed a team, and she and Jeff Hall, the director, just did a magnificent job of fundraising, even during COVID when everybody else played dead. And they had a wonderful story to tell, and they rarely asked for money. I think this is important. They simply got people excited and wanting to be part of this great story that they were telling. And when they brought people into the fold and got them excited about it, the people would ask them, "How can we help?" It was an amazing story, and one that's quite unique in my experience.
That's great. Alan Dyer is watching on Facebook. His question is, are the historic telescopes like the Pluto astrograph open to the public as part of a typical visit? And the old historic library rotunda. It was wonderful to visit. Thanks.
Thanks, Alan. And I know you're a good friend of Klaus Brosch, who speaks of you highly. Yeah, all the stuff that Lowell used to do for the visitor experience is still happening. The telescope viewing on good nights, you can view through the 24-inch refractor. The tours of the Pluto Discovery Telescope, the Rotunda Museum. In fact, over the next couple of years, we'll be redesigning the Rotunda Museum and, redoing that kind of, not to the scale of the Astronomy Discovery Center, but upgrading it and bringing in some new exhibits. So all that stuff is still part of the experience. And that was important to do that while the ADC could certainly be a standalone destination, there's all this other stuff about Lowell that makes the whole visit unique that we want to make sure people still have access to.
Yeah. and we'll want to preserve the character of the rotunda.
Mhm.
Even though the exhibits will be modern.
And that certainly was a big consideration of, we don't want to change who Lowell Observatory is. It's still,
Right.
we've still got this strong heritage of astronomy, communication, research, and outreach, and we want to maintain that.
Yeah, it looks like Lowell has made steady improvements all the way around. That Pluto astrograph is incredibly well restored. It looks like it's brand new. Yet, I mean, I think every part on it is either original, or if it's not original, it certainly looks it. So,
Right.
yeah. How do people get tickets to go see this, the Astronomy Discovery Center?
Well, it's pretty easy. You can get tickets online, or just show up.
At lowell.edu, is that correct?
Lowell.edu, the website. Yeah,
Okay.
or just show up. I mean, opening day is going to be a little bit different story. It's going to be there's going to be a lot of people there, but in general, I mean, you can get tickets ahead of time. That might save you a little time, but you don't have to. You can get them on site.
Just walk up and get them.
Yeah. Mhm.
Mm-hmm. That's great. And you might bump into Kevin there, and or any of the interpreters that are at Lowell. I mean, one of the things I really notice is how well that they perform, in sharing the night sky and sharing the heritage of Lowell Observatory, and just being there. It just feels energetic, You've got many young interpreters there, and at first you're kind of thinking they don't know as much as someone that's been spending decades in it, like you have, Kevin. But they've been trained quite well, and they're very enthusiastic about it. They get the spirit. You can feel it.
Right. And so many of them are astronomy physics students over at Northern Arizona University. So it's a nice kind of partnership almost with them.
Excellent. All right, guys. Is there anything else you want to say before we wrap up?
Well, just thank you, Scott, for this opportunity. It's great to see you, and great to share this story with everybody.
Yeah, that's great. I'm glad you guys did this. So thank you.
Thanks.
You very much. There is one last question here from Frank Florian watching on Facebook. He says, will the facility operate year round, or are there planned closures of the facility at certain times of the year?
Hi, Frank.
It'll be year round. It'll be closed for select holidays, Christmas, Thanksgiving, that sort of thing. But pretty much, it's year round.
Yeah. All right.
And I might just add one more thing there. Sorry for a little more time, but one of the things with the observatory in the past is we'd have people, visitors might want to come up, but it was cloudy. So they decide not to come up because they think of the observatory as a clear weather place. Well, the Astronomy Discovery Center is an all-weather place. And in fact, I would say, when the weather is kind of cruddy outside and you can't go hiking, you can go to the Astronomy Discovery Center and have a great experience. So I think it's going to be interesting to see how it changes our visitation, weather-based visitation.
Sure. Excellent. Okay. Well, I can't wait to get there. I'll be there. Ian will be there. Kevin, of course, will be there. David Levy will be there. Many of my friends plan to be there as well. So, and I hope that those of you watching join us as well, because it's going to be a real experience. So again, thanks, Kevin and Ian, and we'll be talking to you in person very soon. So
sounds good. Thanks.
Thanks, Scott.
Okay.
Thanks, everybody.
Thanks. Okay, our next presenter, we're going to go down to Argentina to Cesar Brolo, who is set up on his balcony. And Cesar, are you all set to go?
Yes, I'm setting something, but
okay.
I'm going now to connect. Bueno.
Take a moment here. So we've had some great presentations so far. Really, really happy about this. And also some great people in the audience asking some interesting questions. And there you are, Cesar.
Well, tonight I have made a short presentation. I'm making some exposure from the balcony. I'm trying to use something that is very easy to use. It's an entry-level National Geographic telescope, which have 4.5 inches and a very short focal length over the XS100 mount, and with a planetary camera. One time last year, I used the same setup for make pictures of Omega Centauri cluster. Tonight, I'm taking pictures from, I am pointing to 47 Tucana cluster. I'm trying, if it's possible, make some pictures of Tarantula Nebula. The position is okay, but maybe later I make some appointments, some lights to make a better how do you say, a better stacking pictures. I use auto stacking pictures, but the idea tonight is maybe I can, let me see if I can share my screen from some kind of pictures, how I assembly or this setup in the balcony a few hours ago.
Is it windy there tonight?
No, it's a quiet night.
Good.
This is gray.
Yeah, we got some wind here. We did have clouds in Arkansas, but they all blew away. So.
Well, here, first of all, talking with the audience, is the first pictures that I showing is how in two regular bags I have here the tripod. I can show you so much better the equipment. This one is the tripod. It's very small. This is the mount, and here is the telescope with the camera.
Okay, Cesar, you might want to stop sharing for a moment if you're going to show your setup there.
Okay. You're watching the pictures.
Go. Okay.
Yes.
All right. That's
2 hours ago. Yes,
Wow, that's a nice view. That's a very nice view.
Yes. Very nice. Was a very It's an excellent night. I don't have pictures ready, but later maybe I can share with you some picture because it's maybe something basic because I'm using a planetary camera, but I think that I can take some picture maybe near to the end of the star party.
Okay.
Well, here is I'm connecting the cables, the wires from the rack ascension to the declination motors. This is ready, the connections between the electronics and electronics for declinations and motor.
Great.
the mount is ready. The bar, the counter bar, is ready too. This is the camera.
I see.
The camera is going to be placed in the same place where you put the eyepiece normally to watch.
Yeah.
Well, another part of the setup, computer, cable, wire from the camera to the computer, and wire from the mount to the computer. Or I can use the cell phone with application that I have the same. I can make all by Wi-Fi mode.
Yeah.
Now is the red light ready, and the green light say that is all connected. Well, the red dot point for this the finder, and all is ready to use. That I made it now. I using the telescope, searching this in this side of the sky. Of course, it's impossible to see between these two buildings. We have the large Magellanic Cloud, and in this area the small one.
We have
maybe I can show you some stars. Of course, that is not so. Let me see if I can show you.
we have an astronomer watching from Twitch tonight, and he's
Oh,
wanting
wow.
to know: are you using any kind of light pollution filters?
Yes, something that is important. I'll share now a view from the camera. It's not something. How do you say? It's not something static, or because it's not finished. It's a live view. There are polar stars in the area of the our polar south sky.
Southern polar stars.
Yes, southern. Yes. But this is a live image of stars. Later, I point the telescope to the Large Magellanic Cloud to try how we can do it, astronomical pictures from a camera that is only for planetary pictures. And this is very important to talk with the people because it's something where you have the opportunity to have a low cost equipment, because maybe you don't need for starting a go-to Wi-Fi mount. In a second step, you can buy this, but you can start with a regular equatorial mount with a AR motor, stepper motor or regular motor to have
something that will track
the rotation of the sky. This is I'm talking for kids, I'm talking for teenagers, or people that they don't know if spend a lot of money in their first steps in astronomy. Today, do you have a real bound for options in a low cost and good quality products This was impossible only 10 years ago. Was impossible thing in cameras that are cheaper or are than less than 200 US average in the world. Do you have the possibility to make nebula pictures? Maybe the brightest nebulas, and with a telescope that is very simple but very good, because you have short focal length, enough diameter to collect light for having a good kind of results, or a good kind of pictures, and have enjoy. You can put, of course, here an eyepiece to watch, or you can put your cell phone with an adapter. Normally in this kind of telescope is provided. Well, it's starting to have fun. This is all for tonight, but it's the first. It's a new time that I return to the balcony to show single astronomy is easy with results that have happiness, you know.
Yeah, very good, very good. And
it's
so
a pleasure.
You're collecting data right now. You're taking images right now.
Not now, because I returned to the South Pole, and
Okay.
I'm going again.
Oh, you're just polar aligning right now. Okay.
Yes,
I don't. How about towards the end of the program?
Maybe if I have,
if you have some images
totally.
you'd like to see. Okay.
Yes,
right.
totally. I choose now return to the South Pole and going again to choose something in the sky, because you know that I have this building that you have sometimes a little of reflection light, parasite light, you know. But I show you the live image just with the stars of the pole. And it's something that are very, very low bright stars. It's impossible to see if you don't, because in this part of the sky, I can see any stars. But I show you in the light, I show it to the audience.
The camera sees it though. That's true.
Yes. Yeah. And it's in a low sensitivity level that I put, because but
I can see how.
I try to the end of the show to make something. Okay.
All right, we'll return to you, Cesar. Good luck on the sky there, and we'll be back. Okay.
Okay. Thank you very much.
All right. Thanks.
Okay. We see you later.
All right.
Hi, Marcelo.
And so now we're going to move up to Brazil, to Marcelo Souza. Marcelo is, I've introduced him many times, but I can't overemphasize the fact that Marcelo is an incredible outreach force in the world, and he has shown many thousands of people, sometimes many thousands in a single event, the sky, to show them a comet or an eclipse or something special going on in the sky. He is the only person I know that knows a person that saw a meteorite fall. Okay. So that was an incredible story. Marcelo has hundreds of amazing stories. He's met amazing astronomers from all over the world, astronauts from around the world. And so if you ever get a chance to go down to Brazil to one of his events, you won't be sorry. So Marcelo, thanks for coming on to Global Star Party again. We're getting closer. Marcelo is also the editor of Skies Up magazine, and we're getting closer to our next issue here. So Marcelo, I think you're muted right now. So
yes. Hi, nice to meet you, Scott. Thank you very much for the invitation. It's a
Yep.
great pleasure to be here. Thank you for your kind words.
Thank
Uh,
you.
Today, here in Brazil, in our city, it is raining since Saturday. We
Oh,
have 1 week of rains
wow.
prediction. Yeah, and now we are not in summer, but we are preparing for the summer. Uh, and this begins the period of rains here in Brazil. Uh, During the winter is the best moment to look to the sky, and now we have many days of rains now. Begins in this period and goes until February. But I hope this year we have days that you have opportunity to look to the sky without rains. I will try to share my screen now. I hope it work well today. My computer ever is, we don't know what they want to do, but I hope that today will help me. I think that worked. Yes, today worked. And I will talk as we can't see the sky directly. I will talk about something that is a special moment about radio astronomy. That this year we celebrate the 50th year of the Nobel Prize about the discovery of the pulsars, the neutron star. And it is a fantastic history that I think that most of the people already know. That is importance of Jocelyn Bell Burnell in this process. She that made the discovery of the first neutron star. She was a graduate student with 24 years old, and she was working at the Mullard Radio Astronomy Observatory near Cambridge. And first in August, she noted a different signal, and her supervisor, PhD supervisor, he was doing the PhD in astronomy. His PhD supervisor said that it will be great to have more data from the signal. And then in November 28, 1967, she had the opportunity to receive again the signal from the same source, and it was something different, as she noted in August, that it was a signal different from other signal that she received when she was working with this radio telescope. And it was something that she first, we know that the first name that she used was Little Green Man. It's like some extraterrestrial life was trying to talk with us. She didn't believe this. Her supervisor also didn't believe, because he worked 1 year ago find different sources that was recorded in radio astronomy, and with the signal that this was when he was recorded August 6, 1967, and then in November 28, 67 or 1967 was recorded again. It's like a message, a short, uh, something that repeat with frequency, and the her device knows someone that was working in a different kind of star. There was a neutron star, and 1 year later they published the first article about the discovery of a neutron star. And this is the image neutron star. I will talk a little about the neutron star before I return to the history of this discovery. This is a representation of a neutron star with the strong magnetic fields that neutron star has, and the stands. You have the the information that you receive here from the poles because of the strong fields. As it is rotating very fast, we receive the signal like I don't know the name that you say in English. That is the light that comes from to advise the ships that is near the Earth. It's like in Portuguese is farol. I don't know the name of this light that changes with frequency, rotating to say to the ships that you have landed there, and it's like this. But I'll find the word in English in a few moments. Then it rotates very fast, and how that appears our from astrophysics, you had a prediction of the existence of neutron stars. As you can see here, the life cycle of a star, very short representation here. I will not. I only show the end here. That is what is important for us. We have a nebula that was the origin of the protostars, and these protostars will have a star depends on the mass of the original mass. You have a massive stars or a star like we live is the center of our system here, the sun, and the average star. The evolution is like it begins a red giant, and then a planetary nebula, and then finish life as a white dwarf. This is the future, almost the future of the sun. And you have a massive stars, begins a red supergiant, and what happens in the center nucleus of the star, you have a nuclear fusion that's producing the elements. You have hydrogen, uh, with hydrogen, you have deuterium, then you have tritium, then you have helium, you form the elements. But when you begin to have the fusion of the iron, this change everything because the fusion of iron the needs energy from the star to then this you have here the energy produced by the fusion of elements in the nucleus. They have equilibrium between this energy and the gravitational field that pulls the elements to the center. Then the star has an equilibrium for a period, but in the nucleus, if you have iron, begins to have iron, the fusion of iron needs energy, then everything collapses to the nucleus of the star, and then this is like a bomb. And after this, you have a supernova, and you have the remnant of this can be a black hole or a neutron star. That's also a very dense star, as the name say, is a neutron because you have the electrons and the protons. You in this process you have the most of the stars composed by neutrons, because of the strong pressure that you have, and then work is like begins, as I said, as something very small and is difficult. Is we can't see using telescopes. But I will show the first image from the Hubble of a neutron star. It was not possible to see using telescopes. Then one way to find a neutron star was with using a radio telescope that you receive the signal sent by the neutron star that rotates very fast and directed the signal. And when he rotates, he sends the information, then rotates again, send the information, and then we record this energy that comes from this kind of star. Oh, sorry. And here is the first article reporting this discovery that was published in the Nature magazine. The name of the article, observation of a rapidly pulsating radio source. Pulsar is used by a journalist that he used this name to instead to say pulsating radio star. They use pulsar, and they use this until today. And this article was published in February 24, 1968. You see the authors here. Anthony Hewish is the supervisor of the Jocelyn Bell, and the last name is Collins, and this article was the first article about the discovery of a neutron star. And this also, and Martin Ryle, well, that also is one of the authors, and Anthony Hughes received the Nobel Prize in 1974 for this discovery, 50 years ago. But Jocelyn Bell didn't receive the Nobel Prize. She was the person that she was a student, a graduate student, but she was at the observatory, the radio observatory, and he was responsible to detect the signal. But she was not included as one of the person that received the Nobel Prize. She's very after this, she became very famous because many people didn't agree with she not to be included in this prize. And I also think that she needed to be there. Is a recognition of her work, but didn't this didn't happen. And here I made a representation of a neutron star, and here is the image most recently of Jocelyn Bell. She born in 1943, if I'm not wrong. Yes, 1943. Then she has 81 years old now, and even she didn't receive Nobel Prize, received recognition in all the world for her discovery. And here is the first reported image of a lone neutron star made by the Hubble Space Telescope in 1997. This is a fantastic image obtained by the Hubble telescope. The first time to have a lone neutron star image in 1997. And as I'm talking about radio astronomy, I would like to talk about another person that for me is a fantastic person, that is Kent Cullers. I don't know if they know, I think that few people knows about him, but if you saw the movie Contact, then you have a character there. This is participating in one of him. Né? Cullis was born in July 1949, and the son of an engineer. His birth was premature, and to save his life, he was placed in an incubator filled with pure oxygen. The excess of oxygen damaged his retinas, leaving him totally blind when he born. His father, that an engineer that liked physics, read astronomy books to Cullis when Cullis was a child, influencing the boy's later aspirations. And he grew up in California, and he was a great student. at school. And he began to study psychology, but he changed to major to his major to physics, and he received his PhD in physics from the University of California in 1980. He is the first totally blind physicist that we in the United States, and also I think that he is one of the first blind physicists in the world, right? And also the first astronomer totally blind that we know in the world, right? Because we have another astronomers that at the end of life became blind, like Galileo Galilei and the other astronomer. But he was the first blind from birth, probably that he finished a PhD in astronomy. You know. And Kent Curtis work, he as a he was blind, and he decided to work in astronomy. That he studied some things that he can't see. You know? It's something that is amazing. And I show that anyone can do what wants. They want, you know? And Kent Curtis will work at SET, net Search for Extraterrestrial Intelligence Program, and she works there from 1985 to 1990, and he was a target search signal detection team leader at the SET Institute. And in one of him, if you who saw the movie Contact, we have a character there that is blind and you work at the radio Arecibo's radio telescope. That is this one here. That is with Jodie Foster here, and his character was created in honor of him. And then she's an example for all of us, no? A blind person that choose to work with astronomy, and he made he was very important research and at the SET program. He died in 2021. Then this was the history that I would like to show today. That's two fantastic persons, that is Jocelyn Bell and Kent Curtis. For me, a reference when you talk about radio astronomy for the importance of their contributions and their examples. And this is what I would like to talk today, Scott. Thank you very much for the opportunity.
Yeah, I did not know about this gentleman. And, during the movie Contact, of course, I was quite captivated by that character. So there are people in astronomy education who work with sight challenged people or even completely blind people. I guess they would also be what we call sight challenged, but there are many, many ways that you can understand the universe beyond vision. And so, through your eyes, because there's vision through so many other things. Just earlier today, I was watching a video, because I didn't know one existed, of Helen Keller. And Helen Keller could not hear nor could she see. And so, but she learned how to talk. And she had a person that worked with her that was kind of an interpreter, and she would move her fingers on her hand, and this is how they would communicate. And it was really amazing. So
we developed here a planetarium for blind people here that we call the unknown universe. That you have a special place, and we put it in 3D representation of the constellations and the sounds of radio astronomy that come from radio astronomy from stars. And also we have a book written that published by NASA that talk you can put the fingers and in braille the book. And it was fantastic because we involved also the population because the guides was blind people, blind students here
Oh,
from our
wow.
city. They were the everybody put a protection on the eyes,
Oh, so they
and
could
then
not see. Yeah.
yes, and then the students was they were the guides inside the planetarium, and they felt like they felt without the vision.
Sure.
And we did this for 3 years here in our city. And
Oh, that's
I will
great.
show next week the images of the
I would like,
that,
yeah, I would like to
that
know
we
more.
did here. And they called the Unknown Universe. That was in the big shop, the biggest shopping center of our city here in Brazil. Now that we had the support and we installed a special place with uh, this representation of the constellations, and it was an fantastic experience for us, and changed our idea. And we also developed projects in a school for blind people that you have here in our city for during 2 or 3 years that we developed this year. And this changed many the ways that we imagine, the life. Something that was for us, it was a fantastic experience.
Yeah, it's wonderful.
Thank you very much,
Thank you
Scott.
for such a great presentation, Marcello,
Thank you.
and we will see you next time. Okay,
Okay, bye.
thank you.
Bye.
Okay, all right, so we're going from Brazil to the bowling alley with Adrian Bradley. And Adrian
Yeah.
is multitasking yet
Yep.
again.
Who's that? So you're seeing some of my buddies that came to tell me my team just hit a grand slam and they're up. They're also here to tell me that it's my turn to bowl.
It's your turn to bowl. Okay.
Yeah. So what I'm going to do is I'm going to do a little quick presentation. We talked about
Okay.
the theme of tonight's program had to do with basically solar streams. It's you wrote a really nice piece about how everything the sun does affects what happens on Earth,
Oh, yeah.
and not just the phenomenon that we've been seeing.
Right.
So what I thought I'd do,
yeah.
So what I thought I'd do real quick, hopefully this works without the sound, because one of the things when you're looking at aurora, it moves, and it takes a while and hopefully it'll allow me to do it. I'm not sure why. Let me cancel start over. I need to do this, share screen. And so I'm going to take you guys inside the bowling alley while I'm doing this, because I'm going to go ahead and throw my shot. And what I wanted to share was when you do a time lapse, such as this, you really see the screaming going. You may be hearing music. If you are, I'll stop it. You're also hearing a lot of people screaming because you're in a bowling alley. So, well, I don't get the bowl yet. So let's stop that and let's look at it again. Different types of music. And I wasn't able to mute the music there. But I got permission from this gentleman to use his music, so hopefully that means we're okay. This one in particular is interesting because you're going to see what happens when the aurora picks up. The streams can come at any time. Look what happens there. And that's something that's quite amazing to see in real time. So, I got volume down here. So I wanted to share that because there's some things that you can see naked eye, and then there's some things that video helps you to see. I'm going to deliver my shot, but video helps you to see even more than what you would normally see naked eye, and it can be quite impressive. And it's all coming from the same sun that we have, and everyone looks at every morning, sometimes takes for granted. So let's see if I can make a spare. Nope. So with that, Miss Spare, that's the end of my presentation. I'm gonna stop the sharing of the screen. But here we go.
All right.
Yeah.
Okay. What we will do, okay, I can see that you're up to bowl here, so good luck on your game.
Oh, I already threw the shot, yeah, and it didn't go very well. But my favorite team's doing well, at least. And at least my buddy's doing well. So get out, exercise, go out and see the night sky.
Sure.
And don't forget to look up, even if you're not doing well yourself. It's it can be quite impressive to see the effects of what the sun does. And I have a feeling, Scott, we're going to have a lot more before this is over, since we're approaching maximum. I think there's going to be some bigger displays. Do you think
apparently we've already gone through maximum, but you know, it takes a while for things to calm down. So, you know,
do you think we've got another big auroral display coming?
I've got a great video too that I'm going to show. It's only a couple of minutes long, but I'll show it to the audience. It's of the sun, and you know, showing when that really big sunspot was. I'm showing. Oh,
I remember that.
It's that big.
May 10th.
It was naked eye, you know. So,
yeah, I remember that. And
yeah,
the aurora it produced. You know, I would wish, and now that it's not my turn anymore, I would wish for everyone to see the aurora the way we saw it when that big sunspot was there. I'm gonna try and share the image that I got. Yeah, those images weren't even were from that aurora. May 10th. And as the story goes, as I flip through here, I felt it looked like somebody was shining a flashlight as it was getting darker. And I said, someone cut off that flashlight. We're trying to film the aurora. And it shined in my eyes again. And I said, listen, someone's got to turn off the flashlight.
Yeah,
stop
messing around here.
Stop messing around. And I turned to see, okay, where's this light coming from, and who am I going to have to give a stern talking to? And yeah, we're going to get to it. Here we go. You know, give a stern talking to somebody, and I looked up and saw this.
Wow.
I would wish for everyone.
Yeah, look at that. Is that cactus?
No, that's just a tree that I used to try and frame the shot.
Up. Looks like you're reaching up to this spectacular display in the heavens.
Yeah, and it's right above it. That's so the curtain like this, you see it in the distance. That's when you're a part of the curtain. It's right above you. Those the things are getting ionized right above you. And that's an experience I would wish for everyone to have. So Scott, since it's just about my turn again, I'm going to go ahead and go, but to the those who are watching, you know, there's some amazing things that happened this year. Maybe a year in review if we do another global star party. That would be I think that'd be a great topic, because there were a lot of great things that happened this year. Folks that, you know, I never thought the aurora would look like this at my latitude, but it did. So I was thoroughly impressed with that. But
it would be.
Yeah,
that's great.
Yeah. Well, thanks for having me on.
Thank you,
I'm gonna go
Adrian.
finish my abysmal game. At least my team is up,
Okay.
and
All
I'll
right.
see if I can at least throw one strike this game.
Throw a strike, dude. Okay.
Throw a strike. All right. Thank you, Scott. Thank you for having
Take
me.
care. Bye-bye.
Yep.
Okay. I think we'll check in. Caesar, are you listening in at this time? We can check in with you. And if not, then I've got this video that I want to play here. So I know Ian and Zizo, I guess that's how you pronounce your name. Adrian does make some beautiful nightscape images. So I think he even sells them. So you can check Adrian Bradley on the internet and find some really amazing stuff. But this is about that giant sunspot. I thought you guys might want to see this.
This sunspot is a huge deal. In spring 2024, NASA's Solar Dynamics Observatory captured the biggest sunspot we've seen in almost a decade. At almost 14 times the size of Earth, it was so large you could see it with your own eyes, using proper eye protection, of course. Sunspots form due to intense magnetic forces that block some of the sun's heat from reaching the surface. As a result, sunspots are cooler than their surroundings and appear as spots with a central dark area, the umbra, and a lighter outer area, the penumbra. Sunspots are frequently linked to solar flares, which are among the most powerful explosions in our solar system. This sunspot produced more than 100 flares and triggered several Earth-directed coronal mass ejections, which are explosive outbursts of magnetized plasma from the sun, resulting in the historic May 2024 solar storms.
Yeah, so if you guys watch that with your solar filters, I think that was really cool. I see that Robert Reeves is here. Robert, can you hear me? He may be having dinner. Okay, all right. So, look, I think that I want to, thank everyone for participating. We do have a couple of extra presentations to give here. We have Carlos Hernandez, who is hurrying home at this moment. He'll be on in a few minutes. And if you guys give me a couple of minutes in between this gap, we will continue on with the program. So just bear with us and we'll be back. All right, guys, thanks for hanging in there with us. We have on with us right now Robert Reeves down in Texas, and Robert is our much more than our resident moon expert. He is someone that poetically and very how do I say this? Technically describes the moon for us. And so, you know, I wish early on into my hobby as an amateur astronomer that I had learned more about the moon. I can tell you over the last couple of years that I've learned more about the moon from Robert Reeves than anybody. So, Robert, thanks for coming on to the Global Star Party again.
Well, thank you for having me. It's been a while, but a lot of water's gone under the bridge. But
Yes.
Here we are, and ready to rock and roll again.
Great.
The general theme I thought was dealing with solar wind, solar stream, so forth.
Yeah.
So I
Did.
thought I
Also-
would talk a little bit about how the solar wind affects the moon. And it does so in profound ways that many people don't realize. And one of the net effects of the interaction of the solar wind and the moon can be seen in the great push to go back to the get manned expeditions to the South Pole of the moon, where we believe there is water on the moon. And the solar wind has a lot to do with the creation of this water. So let me see if I can get screen share working and go to, boom, it appears to be working. Great. First slide up, not the moon, but the sun. Now, we understand the solar wind originates from the sun. It's this flow of hydrogen and helium that is rushing outward from the sun, velocities of well over 1 million kilometers per hour. This stuff streams out from the sun, sweeps past the Earth. Let me get my slides going here so I don't overtalk myself. And not only the solar wind, but occasionally we have these coronal mass ejections. And these get a lot of play lately because they trigger the marvelous auroras that we've been seeing lately. And also, if a coronal mass ejection is strong enough and directed toward the Earth, it can have a profound effect on the performance of our satellites in orbit, our communication satellites, or weather satellites, even power transmission through high tension wires here on Earth. Real strong coronal mass ejection can disrupt that and have pretty significant effects on the Earth. And these coronal mass ejections, if they arrive at the proper time, they can have a great effect on the face of the moon as well. We'll see how here in a second. We see this diagram where the moon is emitting the solar wind, the coronal mass ejections, all of the stuff is spraying out into space in all directions. And in this slide, we see the Earth has our magnetic field that protects the Earth from a lot of this. The solar wind will wrap around the magnetic field of the Earth and stream around it. And some amount of particles will become caught in the magnetic field, funnel down. We see them as an aurora. And if that coronal mass ejection is strong enough, can disrupt that magnetic field, the impulse will be felt directly on the Earth. And we pray that we don't have what we call a Carrington event, where a solar mass ejection is so strong that it would destroy Earth's electronic infrastructure. So, kind of keeping that in the back of our mind, bear in mind that the moon orbits the Earth in an orbit that takes it in and out of the Earth's magnetosheath, the magnetic field that is protecting us from a majority of this radiation. So the moon can swing out of the magnetic tail, be off to one side, or even in front of the moon, the Earth, between the sun and the Earth, and bear the full brunt of the solar wind or coronal mass ejection. Now, bear in mind the solar wind is made up primarily of hydrogen gas, hydrogen atoms, and it's about 4% helium. And while this does have an effect on the moon, a slow erosion effect, which I'll explain in a minute. A coronal mass ejection has up to 20% helium, a heavier atom. And a coronal mass ejection, if it goes on for 2 days, is strong enough that it can actually strip off 1 to 200 tons of material off of the moon by eroding it atom by atom by atom as this fierce solar wind and this bombardment of helium atoms strikes the moon. And that's about 50 times greater than the erosion from just the solar wind alone. So we tend to think of the moon as a very rough, rugged place. And a look through a telescope along the terminator will give you that impression. A very rugged, sharp, impact chiseled surface, kind of reminiscent of a view like this. But in reality, much of the moon is much softer, more rounded, not so sharp and angular. And in this view, we can see the twin craters near the middle kind of look like owl eyes staring back at us. That is Isidorus and Capella on northern Mare Nectaris. And then the little pear-shaped crater off to the upper left, Torricelli. And we see a lot of other territory surrounding it that looks softer, not quite so angular or sharp. And here we see the same thing, the Pallas and Murchison, a similar crater pair on the left. And we see a lot of territory that is just not sharp and angular like it does on the right, but over on the left, duller and more smooth. And this effect we see also on the older craters. The younger one on top is Werner crater, the one on the bottom, Aliacensis, much older. And you can see the physical contrast between them. Space weathering, the constant erosion by the solar wind, the constant rain of micrometeorites chipping away, just chip by chip by chip. And this goes on not for thousands of years, not for millions of years, but it's been going on for billions of years. So at any place on the moon, you can have about a square meter size area, and you don't need to get but a strike every couple of years in that area. But over a period of time, over billions of years, it's like it's been sandblasted by an industrial sandblaster, smoothed down, worn down. So the solar wind, as part of space weathering, helps smooth out, dull down lunar features. This particular one, Alphonsus and Ptolemaeus on the left, and almost mirroring them, Hipparchus and Albategnius on the right. I remember when I took this picture, gosh, it was over 10 years ago. And I remember looking at it on the computer screen as I was taking it. And I said, someday I'm going to write a book about the moon, and this picture is going to be in it. Well, I've done that twice now. Got 2 books out, and that picture is in both of them. But you can see these aged craters are smoother. Now, some of that is in part due to the deluge of debris thrown out by some of the basin impacts. If the crater is old enough, like Ptolemaeus at the upper left, it is filled in and smoothed by ejected from the Imbrian basin. So this one's very old, predates the Imbrian basin. But other craters that are younger, they are slowly sandblasted down to they get this smoothness. But at the same time, this solar wind is striking the moon, and the hydrogen atoms from the sun impact the surface and react with mineral oxides in the lunar regolith. Much of the rock on the moon, the silicon, titanium, various other minerals are in the form of oxides. So there is oxygen in them, and that solar wind hydrogen atom strikes it and combines with a hydrogen atom. It becomes a hydroxyl, a molecule that is 1 atom of hydrogen, 1 atom of oxygen, not H2O, but HO. And then eventually another hydrogen atom comes along, and we get H2O. Now, of course, in the vacuum of space, we can't have liquid water or it evaporates. But on the moon, this water can form literally molecule by molecule and be in the soil. And of course, the sun has another effect on the moon. It heats it up. The lunar day is about 14 Earth days long. So the surface of the moon near the equator can be well above the boiling point of water. And as this water gets cooked out, but the solar wind and the electrostatic levitation of various forces on the moon make these water molecules dance and levitate. And the solar wind will slowly migrate them to the northern regions of the moon, or sometimes even escape the moon entirely. But enough of them migrate slowly over eons. Finally, they get to the northern parts of the moon and they fall into these permanently shadowed craters that never see sunlight. These things on these permanently shadowed craters on the northern part of the moon, in the North Pole, are the coldest place that we know of. I read somewhere recently that there was a colder place in the solar system. I forget what it is. So I will call these perpetually shaded polar craters the second coldest place in the universe. Colder actually than the planet Pluto, which is 4 billion miles away. But
so I don't know if the audience paid, everybody's paying attention to this segment that you're talking about, but this part where you're talking about how water molecules dance on the moon. Okay. This is amazing. This part is amazing because you're explaining where ice forms in these cold bastions on the moon and these deep recesses and stuff. And this is important stuff. It
is the future of manned lunar exploration.
That's right.
Finding this water.
Yeah.
And this is how some of it formed over millions and billions of years. Now, it's not pure water. There's quite a bit of other material mixed in with it, carbon monoxide, carbon dioxide, various combinations of that basically form forms of alcohol. So that has to be strained out, filtered out, distilled out before this water is good for human use. But it is still water, which humans need and rockets need as fuel. Hydrogen and oxygen is excellent rocket fuel. So these molecules slowly dancing toward the northern poles, the northern and southern poles, and eventually falling into these craters and freezing and becoming hopefully substantial layers of ice that we hope to find very soon. We've got missions ready to go to the moon just within the next several months under the commercial lunar I forget the exact name of it. It's the CLPS, Commercial Lunar Payload Services. Yeah, the program that NASA has where they buy rides to the moon on commercial spacecraft. The first one to go up earlier this year didn't quite make it. It had excess horizontal velocity, broke one of the landing legs, fell over on its side, but nonetheless, it made it. So there's more of these in the pipeline. And very soon, we're going to be landing spacecraft, unmanned spacecraft at the south, near the South Pole, and seeking this water ice, making sure that it is really there. So the South Pole of the moon kind of hard to spot from the Earth. The foreshortening of the territory becomes rather extreme. Here we're looking at the lower limb of the moon, Bailey crater, the large basin elongated at the very bottom of the moon. Here we've got Moretus crater and the various itinerations of the Newton craters and the shadows below it. And that, if you can see my cursor dancing around, the shadow line going down along here points to the South Pole on the moon. And get the next slide up here. We see the similar effect. Moretus crater, again, a very common landmark to set the location, Clavius crater up here where my cursor is dancing around. But here we still see the overlapping various itinerations of Newton craters, A, B, C, whatever, and they make a channel that leads down to the South Pole. And right here, this little sliver being struck by sunlight, but I'm circling with my cursor, Malapert Massif, one of the 9 landing sites, potential landing sites named yesterday by NASA for the Artemis 3 mission, where the next crew to go to the moon will land. It's been 52 years since Apollo 17 lifted off. We are long overdue. This particular picture, taken by my friend Don Pettit, the astronaut who is now on the International Space Station. He took this picture from his backyard in Houston with a Celestron Evolution 925, and he graciously let me use it in my new book, the Photographic Atlas of the Moon. And again, it shows Moretus Crater, the channel made by the various Newton craters leading down to the South Pole right around here. And here we see that Malapert Massif just poking up into the sun. These areas at the South Pole, many of them are in perpetual sunlight because the inclination of the moon's orbit is, or axis is so shallow that the sun just rolls around the horizon. On Earth, we get that effect at certain times in the polar latitudes, the land of the midnight sun, but Earth's axis is tilted even more, 23 degrees, I think, versus the 1.5 of the moon. So there are regions on the moon's poles where the sun never sets, yet these heavily cratered shadows are nearby. Heavily shadowed craters are nearby. So not only are these areas where you have permanent solar power for a lunar base, there is a ready well of water nearby as well. So this water on the moon that is generated in part by the solar wind is the key to future manned lunar exploration. And just yesterday, NASA released the candidate sites near the South Pole where Artemis will land, and eventually we'll be setting up a moon base at one of these regions. Personally, I think it'll either be on Mons Mouton Plateau, which is very broad, very flat, relatively. I mean, this is about 60 kilometers across, but the elevation only changes about 1 kilometer. So that's relatively flat. A lot of these others, like the peak near Sabaeus B or Malapert Massif, some other regions around here, they're at the top of some extremely high peaks that rise 6 kilometers. So your navigation to land a spacecraft on that peak is going to be critical. And now that's why I think they'll probably be initially landing on Mons Mouton Plateau or the broader area of Malapert Massif instead of on one of these mountain peaks. They've got to have a couple of unmanned test flights of the Starship to make sure that it will land okay, and geologically investigate these regions to make sure they're seismically stable. You have seen the illustrations of the Starship on the moon. It's tall, almost 150 feet tall. Darn thing looks like a monument on the moon, sitting out on these little tiny landing legs, not this broad, huge spidery legs like the old lunar excursion module in Apollo, but fairly narrow footprint. So that place must be geologically stable. But one of these regions is going to be the Artemis landing site, and the key to it, perpetual sunlight for solar power, and near these perpetually shaded craters that never see sunlight and may have vast amounts of water in them. And I hope you have a better understanding of how that water may have come into being now, just literally molecule by molecule over billions of years, just migrating up there one by one, accumulating with all the other trash. But it's there, and it can be mined and evaporated and distilled into a useful resource. So
what an incredibly precious resource it will be. you know, I mean, my God. So,
Well, the other 6 Apollo landing sites have been immortalized in print and in film for a half a century now. But one of these sites is going to be the new 21st century Tranquility Base, and the official NASA timeline for it, 2026. We can assume that's fiction. That's just not going to happen. Internal NASA documents are targeting somewhere in 2028. So it's going to be about 4 more years before we see footprints on the moon again. But it's coming, little by little. It's on the way.
yeah. Yes, it is. So, well, it'll be very interesting to see. You know, I know I will be holding my breath as they land, just like I did for Apollo 11. You know,
Me too. I was an adult when Apollo 11 landed, and I remember it very well.
Yeah.
The whole lunar program. I remember it. We first started sending the pioneers up to the moon when I was in grade school. The Rangers finally made it to the moon when I was in high school, and then Lunar Orbiter and Apollo. Well, I was an adult. I mean, I was in the Navy then, so definitely an adult. I was off to war. So, but now, half a century later, we're going to do it again.
right. It's awesome. Well, our audience is happy to see you back.
Glad to be back.
Yeah. Let's see. Zizo 1984 comments. I also heard the Luna landing sides need to be planned really well because of the earthquakes happening all the time.
Well, that's what I said, to make sure it's seismically stable.
Yeah.
Yeah, I've heard the discussions about potential moonquakes in these areas, and that needs to be resolved. Like I said, we are sending unmanned probes up there very soon, literally within months, and they will be checking this out to make sure these hypothetical or postulated moonquakes are not a reality. If there's a lot of shaking and rattling and rolling going around there, it's really going to alter plans a bit.
Yes.
The Starship may have to be set aside for more benign landing sites and then jump straight to Bezos's Blue Moon lander, which has a broader landing gear on it, more stable. So we'll see how it develops. This is not a cut and dried, laid out plan.
No.
I'll give you a clue. The January issue of Astronomy Magazine, the cover article will be about Artemis, and I wrote it. So I'll be discussing stuff like that. The trials and tribulations facing the Artemis program and how to get to the moon, and the architecture to send men back to the moon.
Oh, very cool. That's great. Okay. All right. Robert, thank you again so very much for coming on to Global Star Party, and hope you can make the next one. Our next Global Star Party will be our 161st, of course. The theme is discovery already. And, yeah. And
play into my hands.
Yeah. And it is going to be, was it November 12th? So there you go. November 12th. So I'll be sending out an RSVP here probably tonight, and hopefully you can make that as well. So that's great.
Looking forward to it.
Okay. All right. Thanks, Robert.
All righty.
Okay. So let's see if we can bring on Cesar. Are you available? I think he might be in there making a pizza. Okay, I want to show you guys something. Let me bring on.
Hi, Scott.
Are you there?
Yes, I'm here, but it's complicated and to have something now, but I promise for next week I have some pictures ready, some image. Because some reflecting in the from the buildings, 47 Tucana, and it's impossible to have a good position to have because if I show this, is not the idea of quality that I like to show. Actually, I'm near to the objects, but I prefer a white half hour more to take the pictures, or maybe in the week, maybe not from the balcony, if not from the top roof. It will be without reflections from well, look the plane.
Right.
Yes. From the building, because the contrast of the image from a reflector maybe is more difficult to make in an area between buildings. About the parasite lights, this is the problem. But the telescope with the camera work very, very well, very sensitive, and it's a great idea, the kind of this telescope, because maybe in the audience, or for example, kids that they received the gift last year of the telescope in a altazimuth mount, but they can think in have for this year if they are going to have go to mount and this kind of cameras, or using their own cell phones, they can have a good choice, like a product, like a telescope, like their own observatory. Many times we talk about this, Scott, about encouraging the people to use not only the high level stuff or gears. If not, this kind of tubes are excellent. It's something that maybe when the people say, "Oh, I need a go-to mount," or "I need," no, you can start having the tube over a single altazimuth mount. The next year, acquire or buy a equatorial mount, go-to mount, and they are growing in the activity and a camera too. And this is the idea of this. If you agree, I complete in the week the pictures.
Sure.
In a single way, without a lot of processing. If not, an idea of a kid can make with a free software.
Without a lot of expert processing and stuff, but
single process with free. Absolutely, Scott.
Okay.
Well, this is my experiment tonight, but I continuing working in this. Next week we are watching the pictures. Maybe some kind of maybe earlier.
November 12th. You have more than 1 week. So
Excellent. Perfectly. Okay.
okay,
Don't
November
wait.
12th.
Yes.
Okay.
Yes, I have. Yes, save the date.
Right.
Okay. Thank you very
All
much.
right, Cesar, thank
by
you so
invite
much.
me.
You have a good night.
Okay.
Thank you.
Good night, Scott.
Good night. Okay. All right. So we are now with um, Carlos Hernandez. Carlos is a longtime friend. He's also one of the best planetary, technical space artists that I know. He sends me amazing images of views of planets from locations where we have no spacecraft, and views from maybe one of the moons of Jupiter or the moons of Saturn. He'll also often send me images of the events of spacecraft taking off or landing or docking. So all of that stuff's very cool. And so I know that he sped home tonight to do this presentation. He's a very busy physician, and we're really fortunate to have him on tonight. But he's also happens to be one of the best Mars experts around. And he's been studying Mars for an extremely long time with some of the best planetary astronomers on the globe. So Carlos, thank you very much for coming on to Global Star Party and doing this.
Well, Scott, thank you for this wonderful introduction. And I hope that everyone enjoys and learns from the presentation that I'm going to be giving on mostly on the current Mars apparition occurring at this time. Let's see, the stair. Excuse me one moment. It's been a little while since I've trying to find out how to share my slides here.
When you hit the share button, you will see several windows pop
Oh,
up.
right
You
there.
have to select the one that you want.
Yeah,
And then you
here
have
it
to
is.
get to it. There you go.
Okay. Well, I'm going to be discussing the current.
And if you want to bring that into presentation mode, it'll go full screen.
Right. I'm trying to see where. You have to forgive me a moment. I'm mostly a Mac user, and I'm going back.
If you go down to the bottom of that box off to the right, there's it looks like there's a screen that's kind of pulled down. That's presentation.
Okay.
I think that's it.
Okay.
Here you are.
All right, great. So here we are at the 2024 Mars apparition. And it's how to observe the planet Mars in 2024 and into 2025. This is a painting that I did of what the Martian North Polar Cap may appear to a future astronaut, in which you can see what's called layered deposits of dust and ice within the North Polar Cap. Mars is the fourth planet from the sun. Its diameter is a little bit over half the diameter of the Earth's. Earth's is about 7,900 miles, and Mars is about 4,200. Distance from the sun, Mars's average is about 142 million miles or 228 million kilometers, which is approximately 1.5 astronomical units. 1 astronomical unit is 93 million miles, 150 million kilometers. The orbital period of Mars is 687 days, which is almost 2 years. It's 1.9 years. And the rotation period of Mars, ironically, is just a little bit longer than the Earth's by 37 minutes and 22 seconds. Now, that is called a Martian sol, SOL, which is a Martian day. The Martian sol is 24 hours, 37 minutes, 22 seconds. Now, ironically, the actual tilt of Mars is pretty similar to the Earth's. Earth is 23.5 degrees, and the actual tilt of Mars is 25.1 degrees. Now, whereas the actual tilt of the Earth varied little over long periods of time, the actual tilt of Mars can actually go from 0, which is almost on its side, to 80 degrees over hundreds of thousands or millions of years. And the climate is affected at that time. And Earth is the densest planet, and Mars is the 4th densest planet. Now, this is an illustration I made of the different Martian seasons compared to the Earth seasons. Whereas most of the Earth's seasons are pretty equal in length, ranging between 89 to 94 days, the Martian seasons are much more irregular and much more longer, especially the fact that its orbit is much larger than ours. And the shortest Martian season is the Martian northern autumn, and its longest season is the northern spring. And it's one's 143 sols, the other's 194. Also, because of the eccentricity or the ovalness of the orbit of Mars, that is one reason why the seasons on Mars are not equal compared to the Earth's. A picture of Mars taken by the Hubble Space Telescope in 2016 shows the what astronomers see in a telescope, the dark, what's called albedo features, and the clouds. At the top, you can see the Mars North Polar Cap. At the bottom, you see the South Polar Hood. And Mars is mostly made up of basaltic rock and dust. And the reddish color of Mars is due to rust or ferric oxide. And that's what gives Mars the reddish color. A picture of Mars taken by the Viking orbiter showing the vast valley canyon on Mars called Valles Marineris that stretches 3,000 kilometers in width, in length, and over 8 kilometers in depth. So it's a huge canyon, largest in the solar system, that exists near the equator of the planet Mars. Over to the left, you'll see dark oval circular features that are actually the tops of the Tharsis volcanoes and surrounded by clouds. But Mars is a very fascinating planet that has been explored over time by multiple spacecraft and landers. A picture of the largest volcano mountain in the solar system, Olympus Mons, which is over 400 miles in width and up to 77,000 feet in height. It's over 2.5 times the height of Mount Everest. And it's a massive volcano. It's considered a shield volcano. It's similar to the what formed the Hawaiian Islands. It's lava coming up and building over one spot. And that's why the Olympus Mons became such a huge structure that over millions of years, the lava kept building up over it and to reach the current height. And the crater at top is the caldera. A picture of Mars taken by the Viking orbiter showing the reddish color and the dark albedo features and the polar cap on top. To the bottom, towards the bottom right above or below Syrtis Major is the Hellas Basin, the lowest point on Mars. And at the center is considered the zero longitude and zero latitude of Mars within Sinus Meridiani. This is a painting I did of the Hellas Basin, which is an enormous basin over 1,000 kilometers in width and up to 8 kilometers in depth that is located over the southern hemisphere of the planet. And within this enormous basin, many dust storms originate because the highest surface pressure on Mars is located within the metabolic basin. Now, the atmosphere of Mars is extremely tenuous. It's mostly carbon dioxide with a little bit of argon and very, very little oxygen. And the surface pressure on Mars is 600 pascals compared to the Earth's 1,013 kilopascals. So the surface pressure on the surface of Mars is less than 1% that of the Earth's. But even so, it can still hold on to clouds and dust and other structures as well. Now, dust storms originate on the surface of the planet. As the solar radiation strikes the surface and heats it up, there's a layer of hot air towards the surface, and right above it is cool air. And so those two airs combine to form what's called dust devils, which are little tornadoes that pick up the dust. Now, if enough of these dust devils form and get together, they can develop into a regional or even a planet encircling dust storm. This is a painting I did showing the dust devils located within Valles Marineris that may or may not develop into a dust storm, but they are constantly seen and have been recorded by the landers on the planet Mars. Picture of the Hubble Space Telescope on both sides, one taken in June of 2001 and the one on the right on September, showing the development of a global dust storm over the planet. It's a dust storm completely encircling the planet, and that's why you cannot see the dark albedo features clearly because of the presence of the dust. And ironically, when Mariner 9 arrived at the planet in 1971, 72, it was completely encircled by a planet encircling dust storm. The painting of the Martian North Polar Cap that I did showing the different layers, and due to the changing tilt of the axis of the planet Mars, it sometimes has deposits of dust, and then it has deposits of ice forming these layers called layered deposits. And that's seen mostly in the North Polar Cap. You can see it also in the South Polar Cap, but it's much more prominent in the North Polar Cap. This is a drawing of the Martian North Polar Cap showing the minimum extent of the cap and the largest extent. And sometimes you have these outliers, these remnants of the cap at the edge of the cap as it shrinks. And you can see these in moderate aperture telescopes, and if you have steady seeing, and they're very interesting to observe. A painting of the innermost satellite of Mars, Phobos, orbiting the planet Mars that I did, and it looks like a giant potato actually with streaks and grooves on it.
It's beautiful, very dramatic.
Thank you. So this is what I believe an astronaut orbiting Phobos would see if they were looking back towards the planet Mars. And it would be a very striking scene. And this is a painting I did. If you were standing on the surface of Phobos and looking towards Mars, this is what a future astronaut may witness if finally were able to arrive at Mars. Now, ironically, plans have been devised in which future astronauts would set up a base on Phobos because the gravity is much less than that of Mars. So if they were to set up a base on Phobos, then they could go back and forth between the moon and the surface with minimal use of propellant. And that's a proposal that's been made for the future. This is a painting I did of Mars as visible from the outermost moon, Deimos. And you can see the planet appears smaller because it is further away. Now, what I didn't mention was that Phobos, being the innermost moon, has an orbital period of 7 hours and 39 minutes, which means that, and it's only a little over 3,400 miles above the surface of the planet. So this moon rises in the west and in a period of about 4.5 hours, sets in the east of Mars. And this occurs twice a day, twice every Martian day. So you have a moon rising in the west and setting in the east compared to our own moon and other satellites that rise in the east and set in the west in accordance with the planet's rotation. And Deimos, being further away, rises normally in the east, but because it's about 24,000 miles away from Mars, its period is about 30 hours. So actually it rises in the east, but it doesn't set in the west until about 2 days later. So you have these fascinating small moons, but they play celestial dancing above the planet Mars.
Is it possible for any kind of eclipses to happen where you would be on one moon looking at the other passing in front of you?
There does occur eclipses, and they have been imaged by the Mars surface rovers, the Perseverance rovers, but the size of Phobos compared to the size of the disk of the sun, which is smaller at the distance of Mars, doesn't cover the whole thing. And Phobos is not circular in shape. It's like I said, it's like a potato. So it does cover parts of the sun, but you never have a total eclipse as you do on the Earth.
I see. Some sort of strange annular eclipse.
A strange annular eclipse, yeah. But you can find it on the internet if you look up Phobos eclipse, and you can see images obtained by the surface Mars rovers.
Carlos, John Ray, who's watching on Facebook right now, he comments, he says, I'd wallpaper my home office with your images. Beautiful work.
Well, thanks a lot. I appreciate it, John. I just try to be as accurate as possible with the information that we have on these incredible celestial objects, and I appreciate it. Thank you. Now, the current Mars apparition will occur, the opposition itself occurs on January 16, 2025, when Mars attains a apparent diameter of 14.5 arc seconds. Now, this is not the largest, this is actually one of the smallest opposition sizes that you see. The largest opposition sizes, apparent diameters, occur during the perihelic oppositions, and what we're experiencing now is an aphelic opposition. Now, the advantage of the aphelic oppositions is that you can see the northern hemisphere better, clearer, and the North Polar Cap compared to the perihelic, where we see mostly the southern hemisphere. And on January 16th will be the opposition, and it will attain 14.5 arc seconds. So currently, it's approximately 8 arc seconds in diameter, which is actually a good starting size to start observing Mars. Because if you start observing Mars now, by the time you get to opposition, your eye will have been trained sufficiently that you'll be able to pick out a good number of dark and light features over the planet. Oh, and the different references there, the L sub S is the longitude of the sun. That's how we reference the position of Mars within its orbit. 0 is northern spring, 90 is summer, 180 is autumn, and 270 is winter. The D sub E is the declination of the Earth. D sub S is declination of the sun. The dec is the apparent the latitude in the sky. The P is the phase of the planet. So obviously at opposition, it's 100%. And the magnitude and its distance in astronomical units. The Mars will be located in the constellation of Gemini, the Twins, on January 16, 2025. And it will be actually located next to Pollux. And it should be a striking scene, which I'm sure a lot of imagers are going to be taking wonderful wide field images of. Now, Mars, as it's moving through its orbit, it moves like all other objects from west to east, but during oppositions, the Earth, which is inside inferior orbit to Mars, starts to gain on Mars, and then as it gets closer and closer, or more actually closer to perpendicular in the orbit to Mars, Mars appears to slow down, stop, and then it starts going from east to west instead of from west to east. And then once the Earth passes the orbit of Mars, then Mars starts to move again towards the west. And this is called the retrograde motion in the sky. And sometimes it even forms a loop in the sky if you were to trace it. Now, this is a picture of myself in the middle with hair a long time ago in 1977, 78 with my good friend Jeffrey Bish, another noted astronomer and engineer, and my mentor, Charles Capon. And this is the 12.5-inch telescope of Donald Parker, who's a very well-known astroplanetary imager. And this was his 12-inch, and he actually later used a 16-inch reflector. But we learned our trade, if you want to call it that, from Charles Capon, who was an astronomer affiliated with Lowell Observatory. And he learned from another astronomer, Earl Schleifer, who took thousands upon thousands of images of Mars over decades, and whose brother was Vesto Schleifer, who was instrumental in discovering the redshift. And they learned from Percival Lowell. So we were actually trained by a successor of Lowell. So we were very fortunate to have made friends with Chick and for him to want to help train us and make presentations on Mars. Now, we are blessed with air and an atmosphere compared to other planets, but unfortunately, that atmosphere isn't always steady. And if you are able to have smooth, laminar, stable air over your observing site, then you should be able to have a steady image of the planet. Now, if it encounters any kind of obstacle, whether it's a building or a mountain or hill or anything else, then it can produce a turbulent air, and what's called the seeing or the steadiness of the image is severely affected. Another thing that affects the seeing, besides the atmosphere and the large structures around you, is what's called the local seeing, and that is like objects as buildings, or in concrete if you're observing near it, and anything that can hold heat will affect your observing. They'll try to observe as late as possible and try to observe, if possible, over grass or objects that don't retain heat. We use different seeing scales. This one was developed by the Harvard astronomer William H. Pickering. It's a scale from 0 to 10, which 0 is absolute worst, the worst. It's a completely useless image. 5 is average, which sometimes you get some diffraction rings, and 10 is absolute perfect, steadiness of the object. And now, living in Florida, I'm currently in California, but we have to enjoy incredible seeing conditions, and that was obvious by the incredible images of the planets taken by Don Parker. And we used to kid people and say that if the seeing was less than a 7 out of 10, we would close down. So, but it was fantastic to have great seeing. Now, the seeing, and I don't believe now, is as good as before because there's more buildings and stuff. But we did enjoy great seeing at one time. Another seeing scale is the Antoniadi seeing scale. It's 1 to 5, with 1 being a poor image and 5 being a perfect image. And so you can use either scale to grade the seeing conditions while you're making an observation. Now, the tools of the trade are the telescopes that we use, and I'm showing here 2 types of instruments. One is the top is a refractor using a lens, and the bottom is a reflector using a mirror or mirrors to produce an image. And you have different types of refractors that use 2 lenses, achromat lens, or if you're fortunate, 3 lenses, triplets, that produce fantastic sharp images that are very high in contrast. But if you don't have a refractor and you have a reflector, if you modify it so you don't use a large secondary mirror and the surfaces are very accurate and use a small a focuser, you can produce images that are nearly as sharp as refractors. But the contrast would be a little bit less for similar apertures, but still you would get great images. These are pictures of my instruments that I have and have used. The one on the left is my original 1976 vintage Celestron that I used to make my initial observations of Mars and the other planets and the moon. And I still have it, and it's an excellent instrument. It's a jack of all trades and produces excellent images. But my current primary instrument is the one on the right. It's a 9-inch Maksutov Cassegrain that produces fantastic images, very sharp, very high contrast, and I am fortunate to be able to use this instrument now. Now, assuming you have diffraction limited optics, whether it's a refractor or reflector or catadioptric, which is a combination of both, the next part of the equation are the eyepieces. Now, in the past, people use different design or type of eyepieces. Here are shown 3 very popular ones. The top one is the Abbe orthoscopic. The middle one is a very common Plossl eyepiece. And the bottom one is a Brandon eyepiece, which all produce excellent sharp images with high contrast. Now, for my personal observations, and I say this because I really use them and I think they're really excellent, are the Explore Scientific eyepieces. And you have different choices here for the planets. They have a 52-degree field, they have a 62-degree field, and even an 82-degree field eyepiece that all produce sharp eyepieces. And in my case, the added advantage is that they're also waterproof. So they're excellent eyepieces to use. And, I tell that Scott all the time.
Thank you.
Now, a way to get high magnifications in instruments without having to resort to eyepieces with very tiny lenses and very, very small apparent fields is to use a longer focal length eyepiece, a medium focal length maybe, with a Barlow, or in this case, a Teller extender that's available at Explorer Scientific. And depending on the degree of magnification that you require, you can go from 2x to 5x. And these are also excellent for imaging the planets as well. Another useful accessory while observing the planets are filters. And the different color filters allow the observer to detect different features over the planets, especially the planet Mars. The red filter on the right and the orange filter are very useful for detecting albedo or dark features, or actually making them sharper. And if your seeing conditions are average, these filters actually improve the sharpness of the image at times. The yellow filter is also used for surface, but it can see some ice features as well. The green filter is for ice features, especially the caps or of ice on the surface. The blue filter is to detect clouds and hazes over Mars. And the violet is also for detecting high clouds and hazes over the planet Mars as well. This is a series of drawings that I produced of what albedo features are primarily visible at different longitudes of Mars. At 0 longitude, Sinus Meridiani that I mentioned previously is located in the center, and next to it is a long bar called Sinus Sebaeus, and to the left is Syrtis Major, which is a very prominent albedo feature on Mars. And there's Mare Acidelium towards the bottom right, which is the most prominent dark feature in the northern hemisphere. And then if we go over to 90 degrees, you've got the Solus Lacus region, and to the right of that is the Tharsis region that contains the volcanoes. And you can see cloud features over this area frequently if this is the longitude that's visible to the observer at the time. At 180 are other albedo features, including Elysium, Mare Serenum, Mare Sumerium. On the 270 degree is very prominent Syrtis Major, is very prominently visible, and other dark albedo features over the southern hemisphere. This is a series of drawings that I did. The top left image is actually an image of Mars taken by my good friend Donald Parker. And I took that as a baseline. And the immediate image to the right, the top right, is the outline of the features that were visible. And then slowly above the outline, I added the darkening of the albedo features and viewed, in this case imaginary, viewed through the eyepiece, until finally you get to the final drawing at the bottom right, which gives the appearance of the planet at a specific time. And this just shows that it's a gradual process and not a question of being an excellent artist in order to produce images that may be compared to photographs. It's actually more of a record for the individual observer in order for them to remember what they observed at the time when they were observing Mars or Jupiter or Saturn or any other planet. These are two observations I made of the planet Mars. The one on the left was on July 24th, 1986, using a 12.5-inch Newtonian reflector at almost 500x, showing the Solus Lacus region to the top left and other albedo features, and the Tharsis region of the planet. And the image on the right was an observation I made nearly 20 years later of the same region. Now, the differences you see is due to the tilt of the planet at the time. And so, on the image on the right, Solasakis region is more clearly visible. Now, there are multiple features surrounding it, like a sunburst that look like canals. But these are actually, if the seeing studied sufficiently, you would see these broken up into dark blotches, and they wouldn't look like straight lines continuously. But because the atmosphere fluctuates, our atmosphere and Mars's atmosphere, you don't always get the clearest view of the surface. So, and because of this and differences in contrast may produce what appears to be canals, or canali, as Schiaparelli saw in 1877. But as we know, there are no canals, no water canals on Mars. There's channels and there's canyons, but no canals, as stated in the end of the 19th century. Now, a trick that may be used for observing the moons Phobos and Deimos, especially towards opposition, is to use what's called an occulting bar, in which a person places a strip of aluminum or wire across the center of an eyepiece. And what this does is it blocks out the glare, the very bright glare of Mars, and if Phobos and Deimos are sufficiently elongated away from the planet, and you have sufficient aperture, you might be able to detect the moons. This is a map that I produced for Explore Scientific that shows the majority of albedo features visible over the planet of Mars. And it's available on the Explore Scientific website, and the observer can download it, and if they want, they can laminate it and take it when they're observing the planet Mars, and to be able to identify certain features. Now, understand that not all these features, dark features, are visible during any one opposition or apparition. It depends on the tilt of the planet, the size of the planet, and the fact that the dust over the surface of the planet sometimes covers these dark features, so it changes the appearance slightly. But for the most part, this is the majority of the prominent albedo features on the surface. And this is a painting I did of a future starship on the surface of Mars. And this is the end of my presentation. And I welcome any questions that you may have.
Yeah, I don't see any questions right now. I did post your link to your articles, and within those articles, you'll find also the Mars albedo map and all the rest of it. But gosh, I'm looking at that spacecraft, and just the kind of open hatch on the side. They're just going to lower people down, I guess.
That's the plan so far as I understand it, yes. And actually, this is an early painting. The latest designs are probably going to incorporate leg on the starship when they land.
Yeah, I hope so.
Yeah, in order to stabilize the rocket.
Yeah.
Yeah.
Goodness. Well, Carlos, you'll find in your inbox, I image processed that image of you and Jeff and Chick. I color corrected it and sharpened it and straightened it up and everything. So let me know what you think of it when you get it.
Okay. I use that picture also to show people that I used to have hair. So
this shows your hair better.
Well, I hope everyone.
I didn't lengthen it, but yeah. So anyhow, very cool.
Right.
Very, very cool. Well, thank you, Carlos. And, you know, I know that you can see Mars now. And so it's time to get out there and start making some observations. So.
Great. All right. Well, thanks again for allowing me to present.
Okay. Well, thank you, Carlos. Thanks for making it. And we'll talk to you later. If any of you have questions later on that you want to ask, just get in touch with me and I'll be happy to get those forwarded over to Carlos. Carlos has helped many people understand, you know, planetary drawing and imaging and observations. And he has many, many stories of some events, including that mysterious flash on Mars that I think you were there with Tippy and Don Parker, and you guys recorded this, perhaps a frozen lake on Mars. Is that right?
Well, actually, unfortunately, I wasn't with them, but they were Tippy and Don and two other observers were in the Keys, the Florida Keys. And they were observing with a telescope when they noticed a bright flash near Sinus Meridiani, over which the bright circle oval, if you look on the map, called EDOM, EDOM. And they saw this bright flash there, which has also been observed in the past by Japanese observers.
Yes. And they predicted when it would come back, and they saw it.
And they predicted when it should be visible.
Yeah.
And they think that it's due to the ice on the surface of Mars and the particular angle of sunlight that produced that flash. Oh, and we forgot to mention that, and Scott pointed this out to me, that they believe now that the zodiacal light may actually be due to dust that's released from the planet Mars.
Yes.
So that's a very interesting theory, and it's going to be further investigated. But for the longest time, we've seen the zodiacal light on the Earth, and we thought it was due to dust, but we didn't know where it came from. But now it looks like it may come from the planet Mars.
Very good. Very good. Well, thank you, Carlos. I think that will conclude tonight's Global Star Party, and I hope to have you back again. I know your time's very tight and precious, but it's great to have you on. So I also want to thank the rest of the presenters that were on Global Star Party as well. I think we've got one more here. And I think Robert's watching in the background there, but Cesar's still out on his balcony. Isn't it bedtime for you? I mean, it's late, right? Yeah, you're muted. Still muted. Still muted.
Okay. No, I say, sorry. I say that it's 11, yes, 42, yes. But
the night's
we
early
take
for
a
an
dinner.
astronomer.
Yes, we take a dinner in Argentina at normally at 9 o'clock, and you know you have the problem is that
Spain.
I start I'm start earlier in the morning, but it's our style of life. I am enjoying astronomy because I took some pictures of 47 Tucana between the buildings with some reflections of light, but I'm still enjoying, for me, the moment. I'm following the excellent presentations that I can follow. Tomorrow I put in the screen in the store every the entire week.
Yeah, I appreciate that.
I put in my reel in the screen of the our showroom of telescope. ever we put the global star party in the screen in a screen in the showroom. It's really something that we enjoy. The customers ask me, I saw that, or it's an excellent point for starting a conversation.
Yes,
It's great. It's great. Despite that I put the telescope for the show, but I still enjoying astronomy. And this is the magic of this. With a single telescope, entry level, and you can make the same. Not you, the people, the audience, of course, and return to the singles, to the simplest things, elemental things. It's great, really.
That's great. Something that we've started to do here at Explore Scientific. I don't know if you guys can see this or not, but we're holding classes in the parking lot. Too much reflections here, sorry. But it's also a great opportunity to photograph our students doing astronomy, and they have a lot of fun in the safety and convenience of being here at the store, and I let them try eyepieces and telescopes and such. So our next event will be November 9th for that. And so I know that's hard for everybody else around the world to come here, but you'll know in your hearts that I'm doing it. Okay, so.
Yes, of course. But this is the capacity to return to say to be astonishing, or like kids. Tonight I watched the Tarantula Nebula by this small telescope with a planetary camera. Maybe it's not the best image, but if you turn to your brain when you was a kid, you enjoy again the things, the surprise of something that is at many like years. It's great. It's great.
Yeah. Cesar, I'm a little jealous of you because when Mars is at perihelion, when closest to the Earth, for you in the southern hemisphere, it's almost directly overhead.
Oh, yeah.
So, absolutely. Yeah. Yes. It's a great opportunity to take pictures with a good scene capacity, a good scene conditions. Ever that we have the planet in a high angle is the best thing. Something that, especially with Mars, that you have Mars each 2.5 years. If I don't know if I am wrong, but I think that the period is 2.5 years when the closest
oppositions.
Right.
Sorry. Yes.
No, oppositions, and I didn't mention it before. You're referring to the synodic period. The synodic period, which is 780 days, which is 2 years and 2 months between successive oppositions. And that's called the synodic period. And as I mentioned before, there's perihelic oppositions and aphelic, but they're pretty consistent every 2.5 years.
Yes, and over this, the opportunities to see something, cloudy nights, the position of the planets. For me, that I don't have a landscape clear. It's a mix between buildings and really when I work with telescope, I sail telescope, but when I have the opportunity as tonight, that is a clear night in the city, but enjoying the things that where you have a planet or something. For example, Saturn was in excellent conditions 2 nights ago. I don't remember from my maybe 20 years that I don't see a beautiful view of Saturn with my small Maxwell telescope of only 4 inches. And this is something like I really enjoy again because the things are like comets that returning every year or 2.5 years, and I say all to the people all the time. They say, you use your telescopes. If you live in the city, use your telescope. Don't put the telescope inside a box. If not, take your telescope or your binoculars assembled in a living room, ready to go to the balcony, to the backyard, because each night, each clear night is a magic night, and you have a lot of opportunity to see something different. Is the real thing.
That's very true, Cesar, because the instrument you have is the best instrument that you can use. Because if you don't use it, then you're never going to experience what you're describing. And by observing more and being trying different nights, and especially leaving the telescope outside, you can observe great images of the planets. And as I mentioned previously, if you can factor in your local seeing, like in your case with the buildings next door or concrete and stuff, if you allow time for cooling, sometimes the best images of the planets are towards midnight or after midnight, or sometimes in the early morning. But you adjust to whatever your living conditions are, and very few people are able to observe in wide open fields. Most people observe from the city, and I wish you the best of luck.
Yeah, thank you very much. And I was following your presentation. That was really, really, really interesting. Thank you very much.
Thank you, Cesar. Thank you.
All right.
You're welcome.
Okay.
All right, guys. Well, have a good night. And I'm going to go home and have some dinner and think about all these amazing talks that came on to the Global Star Party. And it was fun. So, and those of you that are new in our audience that are just now watching or are watching, this in rerun, thank you for joining in with us. Our next event will be November 12th, as I mentioned in the chat. And you can find it at explorescientific.com /, I'm tired, sorry, GSP for Global Star Party, GSP 161, and you'll find the page.
Wow, yeah.
The schedule is not accurate right now because I have to update it as people come on and change their presentations, but it'll be good. Thanks. Thank you, Carlos. Have a look at that picture and let me know what you think about the restoration. And
I will.
Okay. All right. And Cesar, thank you very much. And
have a good night, everyone.
Thanks to you.
Yeah.
Bye-bye.
Thank you, Scott. Thank you.
Okay. Thanks. And before I go, I'm going to show a video that I thought was so cool from the Soho spacecraft of the comet A3. So let's see if I can pull that up. Let's see if this is it. Seconds. Beautiful stuff. Tom, it's been almost a year since we were here last time, and the 100-inch mirror was out of the telescope. We were standing on a kind of a wobbly scaffolding, right?
It was very stable. It was just narrow.
But we had hard hats on.
Yeah, we were safe.
Yeah, we were safe. That's right. And you were starting to explain to me how you do your public observing program, but you use Explore Scientific equipment to make that possible.
That's right.
So tell me how this whole system works.
Well, it's not complicated. Just follow the light. We have the 100-inch mirror, which is right above me here. We were just inside the telescope where we saw the secondary mirror way at the top, a tertiary mirror sending it out to this relay optics system, and then following the light path down to your Explore Scientific T7ED.
Oh, great. So behind us here, we've got the ED-127 airspace triplet. This is a 4-inch starlight focuser that has a custom adapter to attach to this telescope. And then we've got a 3-inch diagonal and a 3-inch 30-millimeter eyepiece. Tom, what's the focal length of the telescope again?
About 33,000 millimeters.
33,000 millimeters. So with this eyepiece, we're going to get
over 1,000 power,
1,000 magnification. So with a 100-degree apparent field, it's about 5.5 arc minutes true field of view. So that is a great view through a very high-powered telescope. And how many people do you have coming through to do your educational outreach programs?
Well, we have the educational outreach as well as the public nights and our client nights. So we've probably done about 800 people this year through this.
Well, it's just a great honor for us to have our equipment used on the 100-inch. I know it's used on the 60-inch telescope. I've used it on the 60 myself. And the 40-inch. So, we got a sort of a trifecta with George Ellery Hale's telescope. And so if someone wanted to rent this telescope, what do? They go on what's the website that they would go to?
mtwilson.edu. And we have pages for both the 60-inch and 100-inch that you can make reservations, and it has all the information for that process on our website.
That's fantastic. All right, well, that's great. By the way, this is also used on the 40-inch refractor earpiece. So they use a whole slew of eyepieces. But you've got a ton of focal length here. What's the focal length of this scope?
I forget the calculation. It's big. It's way long.
Okay, we'll do this again.
Okay.
Here we go.
There's a 101.
It's 101 inch. It's not
It's bigger than they advertise.
Yeah. Okay,
F
101 times 20.
12.6 or F rate. It's 32,300 millimeters.
Okay, so let's do this
that's
again.
long.
That's long, isn't it? Right. So 32,000. So what's the magnification going to be? 32,000 divided by 30. 32,000. That is crazy.
It's about 1,000 power more.
32,000 or 35,000?
32,324.
1,077 magnification.
So 1,100 power.
100 divided by 1,077 is 0.09. It's 5.5 arc seconds, or arc minutes.
Arc minutes.
5.5 arc minutes.
That's
field of
big.
view.
That's
It's not a
impressive.
bad field.
That's impressive.
Okay, so 5.5. Okay, all right. So now we know the numbers. Let's hide our calculator here so nobody knows.
So we cheat on that.
Yeah, that's right.
We could do this in our head, right?
What's the focal length of the telescope again?
About 33,000 millimeters.
33,000 millimeters. So with this eyepiece, we're going to get
Over 1,000 power,
1,000
1,100 power.
magnification. So that would work out with a 100-degree apparent field. It's about 5.5 arc minutes true
Right.
field of view. So that is a great view, a very high-powered view through a very high-powered telescope.